Okay. Gotta get the chat and shit, bruh. Do that. Do that. Oh, that's gonna fucking suck. I didn't realize how bad that will be. Find that P right there. Just gonna need to move this a little bit and hope that looks okay. Oh, and I also gotta change the shit. God damn it. Fuck. Okay. Oh, fuck. You get a bit. What am I on, bro? I'm telling you. What is this? Oh shit, okay, that's cool. Sadly, I won't be doing that. My bad, shit. Shit, shoddy, my bad.
Time for our final
Oh,
topic in section
wrong one.
5.1.
Wrong one, my bad.
Hello, BC Calculus, and welcome to topic number 1 out of section 5.1. Boy, do we have a lot to learn in this chapter in general, as far as curve sketching and the first derivative test and the second derivative test. There's
Fuck.
so many good things to learn in chapter 5. We're going to start out with our first section here, and it's really just a matter of vocabulary and looking at a bunch of graphs. So there is something in calculus called the extreme value theorem, which most people would agree is pretty much common sense. It says that if a function is continuous on a closed interval from a to b, then it must have at least one absolute max and one absolute min on that interval. So we have some vocabulary to introduce to you here, you guys, because there are actually two different kinds of maximums and minimums that a graph can have.
Wait, what the fuck? What? The fuck did I do, bro? My bad.
Okay? And when I take a look at this first graph, we'll label it as graph number 1.
1 second, bro. I need to take good notes. 1 second. God damn, just. What did I do? And also, I need to do that again. My monitor's gonna fall off, bro. That's good enough. The camera's a little fucked. Let me just fix that real quick. Good enough. Okay, my bad, my bad.
The endpoints are going to be numbers that I need to pay attention to. And any other maximums or minimums on the graph are also something that I need to pay attention to. And so this point up here would be labeled as the absolute maximum. Again, probably common sense because on that interval, the graph doesn't get any higher than that. So that's why we would call it absolutely the most maximum point. Similarly, this point down here would be called the absolute minimum. Now, these other 2 points on the graph actually do have names. They do have labels. It's just we can't label them as an absolute max or min because they're not the highest or the lowest points on the graph. So what
Okay.
are the vocabulary words that the calculus world uses for these? Well, they're called relative maximums or
Yeah.
sometimes called local maximums. I kind of like the idea of using the word local just because think of it as like in its own little local neighborhood.
Bum stream. Okay, dude. Damn. Damn. Okay.
He
Damn.
is king of the hill.
Really make me want to
Even though
cry
when
out
we
here, bro.
back out
Damn.
and look at the entire
Damn.
graph, there are other places on the graph that are higher than that, right? But in its little local area,
Damn.
it's definitely a maximum. The textbook will use both of these words, relative and local, and we need to know that they mean the same thing. Kind of similar to that, this would be known as a relative or a local minimum. And it's not because it's sitting in a valley, but it is sitting at the bottom of a segment, okay? And so that's why it's important for us to still notate it as being an important point on the graph. So we're going to call that a relative minimum. Over here on graph number 2, we see that the graph achieves an absolute maximum here at the top and an absolute minimum here at the bottom. there is maybe a little bit of curiosity out there about what would happen if there were an open circle on one end of the graph. And we are tempted to label this as a relative minimum, but no.
Because there's a
If
hole
it
in the
was a
graph.
darkened-in circle, yes, it would be a relative minimum. Because there's an open circle there, it is technically like a hole in the graph, so it's not definable. And so literally this is a nothing. In fact, you can just leave it blank. You don't need to even put anything there. Anytime that we have an open circle or a hole in the graph, you're not required to label it with anything because it's not really representative of anything. So that theme follows us through to this one because we want to say that this is the absolute minimum point on the graph on
God
that
damn
interval,
it,
but we
it's
can't
so
because there's
bad.
an open circle there. So that's a nothing. I think that we would call this a local maximum because locally it sits at a peak, but there are other points that are taller than it, right? So this one up here is what would be labeled as the absolute max. And this one right here, once again, would be labeled as the local minimum. Now, let's talk about that one a little bit further because locally speaking, it sits at the valley of the graph. But there are other values of the graph that are lower or less than that. And so that's why
Bro, what am I supposed to do, Suvi? Man, you just mad cause bad. You just mad cause bad. But yeah, what's up, Suvi? Hello, how are you? Welcome to the stream. Thank you for coming to the stream, I guess. But yeah, how are you?
we can't label it as an absolute minimum. We have to just call it a local or a relative minimum. And you guys are probably getting the hang of this by now, but this would be called a relative or local
I'm good.
max
I'm
because
glad
it
to hear
sits at the
that.
top of the segment, but it is not absolutely the highest point. This one right here would be labeled absolute min because there is no other point less than that. This would be labeled as a nothing because it's an
I
open
come
circle.
in stream to
And
scold you.
over
Yeah,
here, this
makes
would be
sense
labeled
though.
as an absolute
Absolute
maximum.
maximum.
Okay? But relatively speaking, again, this video was just to introduce you guys to some calculus terminology that's probably mostly common sense. And the only function in this that actually did a good job of demonstrating the extreme value
This is the
theorem
first one.
was this first one.
Yeah.
And the reason why is because the graph needs to be continuous on the closed interval all the way from A to B.
And none of them are
And none of these other
continuous
graphs were, you
because
guys.
there's a
There was
hole
a
in the
hole,
graph.
at least at one location somewhere along the way. But
Because the
for this first
tangent.
graph that was continuous, you can see that the graph has an absolute maximum
Bro,
and
what's
an
that
absolute
curve to
minimum.
him?
It also
Sheesh!
happens to have a local max and a local min, but that's not required by the extreme value theorem, okay?
I ordered text photo book
In any
today.
case, that
What? Text photo
introduces you
book?
to a simple
What?
theorem from calculus and also some vocabulary.
A simple theorem. A very the fuck. A very simple theorem, you know. Simple. Simple. My obsession continues. Oh, okay, that kind of shit. Yeah, that makes sense. Yeah, yeah, yeah. I mean, that's very understandable. Damn. Womp, 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 womp. Topic number 2. States use. Oh, my bad. Tomorrow X together. Ah, my bad. Shit. My bad. Okay, bet. Let's go. Sounds awesome. Use the extreme. It's extreme value theorem. I can spell this? Yeah, I can spell theorem correctly. In conjunction. I'm about to be done with calculus. Let's go. With a derivative. You just made me laugh so hard. My bad. Shit, homie. Shit, my bad. To find the extrema. Find the extrema. Or the absolutes. Absolute min, max, and min. Womp womp. Values of the function. Of function. Example. F of x is equal to x tesseract minus 6x squared plus 9. I mean, shit. I'm just waiting so I can pre-order J-Hope's new album. How are you, though? Oh, that's not the best question to ask me right now. That's all I'm gonna say. I mean, if you really want to know, just ask me on Discord later or like tomorrow or some shit. I don't fucking know. But besides that, how about you? Oh wait, no, I already asked you. My bad, CB. My bad. I already asked you that. Shit. Damn. It's okay to not be okay. Oh, I am not. I am not okay. I have not been okay for a long ass time. So you'll be fine. Oh no, I am not fine at all. I mean, wait, you're telling me we can just find the absolute min by just using 4x cubed minus 12x plus 0? And then just... Oh, wait, no, wait, hold up. What? I don't fucking know.
Welcome to topic 2 from section 5.1, and here we are going to put the idea of the extreme value theorem in conjunction with the derivative into action to help find
Ask me
the
about it. I'm
extreme
depressed and obsessed with
values of
K-pop.
the
Okay,
functions,
true.
okay? And so the first example, and we have 3 total examples to look at here, ladies and gentlemen, but this first example is just a 4th degree polynomial, and it happens to be on the closed interval from -4 to 2. And so some things that we want to check for. First of all, the extreme value theorem requires that the function is continuous. Well, I think that we know that most 4th degree polynomials wind up being shaped a little bit like a W. And if I know that this has been closed off on an interval from -4 over to +2, I mean, this is a very sloppy sketch, and I don't know exactly where the endpoints of this W shape should actually terminate, but I'm just trying to get into my mind.
Okay, sorry about that. No, okay, at all. My therapist today was so calm. That's why I was like, he said you're getting better, but your anxiety's gotten way worse. Oh, damn, that sucks. It's a good and a bad. Damn, yeah. People always need a therapist. Nah, I'm good. I'm Gucci. I'm fine. I mean, I'll tell you it later, Suvi. I'll tell you later. I don't want to tell it on stream at all. I don't want to tell you it on stream at all.
How it fits into the idea of the extreme value theorem. Is this function going to be continuous? Yeah, because all polynomials are continuous. And here we are on the closed interval between -4 and +2. Now, why is it that we need to also use this in conjunction with the derivative? Well, what we've been thinking about here in our search for the idea of an absolute maximum and an absolute minimum is that those things can happen for 2 reasons. One of the reasons is if it happens at an endpoint. Okay, so I'm going to go ahead and sort of write that down. This is just my thought process on if I were searching out absolute maxes and mins, these are the thoughts that I would have. It's possible that an absolute max or min happens at one of the endpoints.
Okay, 1 second. Oh, okay, bestie. Fine for me. Sorry if I don't respond because I'm gonna go sleep now. So good night, lovely. Okay, good night, Suvi. Hope you sleep well. Thank you. Hope you have a great day tomorrow. Love you. Good night. Okay. Derivative is equal to 0, which makes sense.
Another reason that it might happen is because you're sitting at a location where the derivative is equal to 0. And that right there is really why the idea of the derivative comes into play, okay? So here's how I think we start this process, ladies and gentlemen, is we go ahead and we make a t-table of values for ourselves. And when we make this t-table, we want to make...
If no one told you to look pretty, I do not look pretty. You're capping. You were definitely capping.
sure that this t-table speaks to all of the eligible candidates. When the AP teachers are grading the AP exam at the end of the year, they talk a lot about that phrase. Make sure that your students include all of the eligible candidates.
Oh, okay.
Well, because the endpoints of the interval that they gave us are -4 and +2, we know that those are possible places where an absolute max or min might happen. So those are eligible candidates that we should go ahead and just put into our t-table right away. Will there be other eligible candidates? Yes, probably. And remember, those candidates happen because the derivative is set equal to 0, okay? And so I'm going to go ahead and take the derivative of my function really quickly, and it's just the power rule. So 4x to the third minus 12x, and I'm going to set that derivative equal to 0. I can do a little bit of factoring here as far as taking out a 4x, and that would leave me with x squared minus 3. And then if I set each of these things equal to 0 and solve them all the way to completion, x equals 0 is on there. And here, well, I'm just going to go ahead and take a square root of it as well. So you would add the 3, and then you would take a square root. And of course, we need to remember our plus minus sign when we do that. What that does, you guys, is it expands the eligible candidates.
Oh, shit,
So
okay.
we need to go ahead and add those to our t-table. So again, any of these can possibly be places where an absolute maximum or minimum occur. How do we find out which one wins, okay? Because that's what an absolute max and min really mean, is the highest and the lowest, okay? And so the very last thing we need to do in the process here is plug these back into the original equation. The derivative was part of what we had to do in the process, but when we're checking for the final answer, we are looking for absolute maximums and minimums on the original function. So we want to make sure that we're using the original function when we plug these in. And I'm doing that on my calculator real quick. And when I plug in the number -4, my calculator says 169. When I plug in 2, my calculator says that I get 1. When I plug in 0, I can do that with mental math, and I just get 9. And when I plug in the square root of 3, I want to make sure, that's also one that we could do by mental math, but I just want to make sure that I'm not making any dumb mistakes here, you guys. And so when I plug in square root of 3, I wind up getting 0. And actually, when I plug in negative square root of 3, I also wind up getting 0. Now, these eligible candidates help guide us to what the graph looks like, okay? And again, this sketch is not going to be super awesome, but it will at least help us visualize what's going on. So over here at -4, this graph is way, 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 way up there at like 169. At 2, we're sitting at a value of 1. 0, we're sitting at a value of 9. Square root of 3, 0, and negative square root of 3, 0. And again, we knew that this was a 4th degree polynomial, so it would be kind of shaped like a W. And if I take a look at that W, here's what I'm dealing with, okay? The last thing we need to do is basically identify who is it that wins. Well, over here, because 169 is definitely much larger than any other value, that is certainly your absolute maximum. And something interesting happened on this one, you guys, where we actually got a tie between 2 absolute minimums, positive and negative root 3, 0. And yes, that does happen. It is possible for a graph to have multiple absolute minimums or multiple absolute maximums. I mean, think about a sine or a cosine graph and how many times those graphs reach that same maximum point over and over again. So it's certainly possible to have more than just one, okay? The rest of these would be labeled as, because it's good to have labels on our graph, this would be a local maximum, and this would also be called a local maximum because both of them sit either on a peak or at the top of a segment, okay? So that's how we use the idea of the extreme value theorem in conjunction with the derivative to help us get all of our eligible candidates so that we can see what our extreme values are. We're now going to move on to the second example.
Let's go.
And our second example is dealing with the graph of e to the negative x. And we're going to be on the interval between negative...
Hold up. God damn. It's be -1 less than or equal to x, while x is less than or equal to 1.
1 and +1. E to the negative x is just an exponential decay graph, so I'm fairly sure it's going to be continuous on the interval. Let's go ahead and get our t-table of eligible candidates started. I know that the endpoints of the interval should be on the graph automatically. Where are the other eligible candidates going to come from? They're going to come from taking the derivative and setting it equal to 0, okay? Well, the derivative of this is going to require our e to the x rules, okay? And we might remember that the derivative of e to the x is just himself, as long as you remember to
e to the
chain
power
on
of
the
negative
derivative of the
x.
exponent out front. So I've chained on a -1. And I'm trying to set this derivative equal to 0. I could divide both sides by -1 if I wanted. And then I believe the next thing I should do is take a natural log of both sides, because that's what typically gets rid of an e.
Mm-hmm.
However, the natural log of 0 is undefined, you guys. That's actually where its vertical asymptote
Oh, that's so
sits.
cool.
So it's totally undefined.
Oh, yeah, that makes
and
sense.
basically what happened is this equation kind of exploded on itself, and that just means that our t-table is done. We don't have any other eligible candidates to add to it.
Damn, okay.
Now, if we bring our common sense along for the ride, okay, this graph at the beginning, e to the negative x, is an exponential decay graph that looks something like this. And if I cut it off on the interval from -1 to +1, we're basically just looking at that stretch of the graph. If we are looking for places where the derivative is equal to 0, in general, that means we're looking for distinct peaks or distinct valleys. But as you guys can see, this particular type of graph does not have distinct peaks or valleys. So that's another thing, kind of tying in common sense to why the analysis of the derivative failed there, okay? Next thing I need to do is plug these back in. Once again, please make sure that you're plugging back into the original function, okay? And if I plug in -1, I wind up getting e to the first. And if I plug in 1, I get e to the negative first. And so this one is certainly your absolute maximum. And this one here is your absolute minimum, which comes from this guy right here. This side was your max and this side was your min, okay? But again, you...
God damn, bro. God damn, bro. I just like
using the idea of the extreme value theorem and the analysis of the derivative to try to find all of your extremities. The last example that we're going to take a look at here has to do with a trig function, okay? And so we are going to deal with the sine of x plus...
The fuck? I did not mean to do that. Whoops, my bad. Shit, homie. X plus pi over 6 with 0 is being less than or equal to
pi over 6. And the interval that we're going to take a peek at here runs between
7 pi over
0
4.
and 7 pi over 4. Now, anytime that a trig function is involved, it's going to be a little bit more of a headache, you guys. So I really invite us to start this one by looking at the graph first. We know that typically the graph of the sine, and I'm going to go ahead and put my trigonometric quadrantal angles up here, you guys.
1 sec. I should actually do that. That's actually good. Okay. God damn. 1, that's going to be the 0 point. 0, that's going to be the -1 point. With this being pi over 2. This being pi. 3 pi over 2, yeah. And then 2 pi. Yeah, it goes like a little funkiness, like... Wait, no, fuck, I fucked it up. God damn it. There we go, good enough.
And we have an amplitude of 1, okay? Typically, the graph of the sine does something like this, all right? Our equation, the way that it's been written, there has been a shift, and specifically a shift to the left by pi over 6. So I'm going to do this in purple, you guys, but it basically means that the behavior of the graph is going to follow what it would normally do, except it's just been shifted to the left a little bit. Okay, so following this purple graph is what we're looking at. Now we also need to think of it in terms of the interval that they've given us. So if I'm going to cut off this graph between 0 and 7 pi over 4, which is right about here, you guys, it's just this section of the graph, okay, that I'm looking at along the way. And I can see that there are endpoints that need to be analyzed, and there is also a peak, and there is also a valley that happens along the way, okay? And yes, if we know about our trig functions, and we know that it's been shifted to the left pi over 6, yes, we pretty much know where those maximums and minimums occur. But we would be missing out on the analysis of the derivative, which is really what calculus is all about, you guys. So we're going to go ahead and go through with that. Let me get my little t-table for the eligible candidates set up. We know that extreme values can possibly happen at the endpoints. And they can also happen at any place where the derivative is
Fuck. God damn.
set equal to 0. So let me figure out what my derivative of this function would be. I think we have a little chain rule here.
Your
So the derivative
cosine
of sine would be
of x
cosine.
plus pi
Leave
over
the inside
6
stuff
times
alone.
1.
And then we're supposed to chain on the derivative of the inside stuff.
That's
But I
useless.
think that's just 1, you guys. So I don't know that we really need that. That's sort of not needed right now. And we're going to take that derivative and set.
Okay, 1 second. God damn shit, shoddy. Let me write down some stuff. So that'd be cosine of x plus pi over 6. So that is 0. Well then, shit, that's gonna be pretty awful, bro. 1 second. God damn, bro. Okay, there we go.
Set it equal to 0. Well, where do we go from here, you guys, if we don't have a calculator on us? There were some trigonometric identities back in pre-calculus that were the angle addition formulas, the angle subtraction formulas, all kinds of crazy things.
Oh yeah, we're supposed to learn about this, but we didn't. Damn.
And I think that the cosine's angle addition formula went something like this, you guys. The basis of the formula landed at something like if you had cosine of u plus v, that you got cosine of u times cosine of v.
Okay, that's a really important fucking formula. God damn. Cosine of u plus v. Fuck, I need to actually. Cosine of u plus v equal to cosine of u times cosine of v minus sine of u times sine of v. What the fuck, bro? That's important as hell.
Minus sine of u times sine of v. And so that was the formula that I was sort of applying over here. And why do I have, this
I
should
was
be a pi over
confused, yeah.
6. I apologize, that's a typo. Okay, so now let me think about my trig circle. Pi over 6 is a 30-degree angle. So the cosine of pi over 6 would be root 3 over 2. And the sine of pi over 6 would be 1/2, okay? And we're trying to set this equal to 0. The next thing I might do is add, boy, I'm really trying to tough this out, you guys. Really trying to tough this out and do this without the help of a calculator. So I'm going to add the 1/2 sine x to the other side. The next thing I might do is divide both sides by cosine.
God damn Okay, you know what? Fuck it. Hold up. I need to do everything better, bro. Hold the fucking phone. God damn. Shit. It was like, yeah, it's gonna be root 3, 1, then 2, I think it would be. Oh, I don't remember, bro. Fuck. And so then, yeah, it would be okay. Fucker. Sine of x equals 0. And you would plus it both sides. And you would have root 3 over 2 cosine of x is equal to 1/2 sine of x divided by cosine to both sides. So then you have root 3 over 2 is equal to 1/2 tangent. Of x, yeah, okay.
cosine, because this cancels, and of course sine over cosine is tangent. The other thing that I might do is divide the 1/2 over to the other side, and so you would
Okay, then so then you would have
divide by two fractions, so keep change flip, and I believe we would get a tangent of x is equal to √3. Now remember, what you're supposed to do in that moment is you're supposed to think about your trig circle and ask yourself, what angle generates this ratio? What angle would we be sitting at to get a tangent of √3? And I believe that it's a 60-degree angle, you guys, because tangent is opposite over adjacent. So I think it has to be at a 60-degree angle. Now we need to remember that tangent, see, in this, tangent is yielding a positive result. So tangent is positive not only in quadrant 1, but also over in quadrant 3. And so the 60-degree angle, which is pi over 3 in quadrant 1,
pi over.
is one of our solutions. But we also need to grab for the 60-degree reference angle in quadrant 3, because again, that's the other quadrant where tangent is positive. And I believe that that would be 4 pi over 3.
Yeah,
Okay?
4 pi over 3.
Wow, we did it!
No,
Using
no,
a
no,
whole
no.
bunch of crazy trig
5 pi
identities.
over 3.
But those are the other eligible candidates that need to be added to your table. You guys, pi over 3 and 4 pi over 3. So here we go, pi over 3 and 4 pi over 3. And we can kind of tell by the graph that the value at pi over 3 is going to be 1. I have the hiccups. And then the value at 4 pi over 3 is going to be down here at -1. The value at 0, well, I might need to actually plug that back into the original equation. If I plug in 0, that would give me the sine of pi over 6, which I think is 1/2. And the last number that needs to be plugged in here is 7 pi over 4. So I think I'm going to need to scroll down, you guys, and kind of take some time to figure that out. Sine of 7 pi over 4 plus pi over 6.
Oh,
Let me
fuck.
work on getting a quick common denominator here.
Times 3. The fuck? Man, I don't fucking know.
My common denominator is going to be 12. Okay, so I would get 21 pi plus 2 pi over 12, and that would become 23 pi over 12. And oh my goodness, I think I might kind of sort of either need to use the sines angle addition formula or just reach for my calculator to get the
That's a very important formula. Hold up. I just realized how fucking important that is. It's gonna be. I need to write that down, actually. That's super important to know. If it would. Stop it! Ah! My bad. So if I have cosine of u plus v, that's going to equal cosine of u times cosine of v minus sine of u times sine of v. That's a very important formula to know.
the answer, you guys. So in the interest of time, we're going to go ahead and say that that part is unfinished. But looking at the graph, okay, the analysis of the derivative and the fact that we used the derivative to really nail down the exact locations where this maximum and where this minimum occurs was what was most important. And so this one right here would be labeled as your absolute maximum. And
Jesus
this one right
Christ,
here
dude.
would be labeled as your absolute minimum. And that's how that extreme value function analysis
That's so
goes,
cool.
you guys. Some are
Oh, that's so cool. Okay, then. Okay, my bad. Topic number 3. 3 states critical points. Critical points. In calculus, yeah. Critical points. Point occurs. Do not spell. I do not know how to spell occurs. Apparently, god damn. Occurs on a graph. Fuck. On a graph wherever the derivative is equal to 0, or where the derivative is undefined. Usually this means a max or min on the graph but can also mean excuse me, a vertical asymptote. It's a gap or an inflection point. So the example, I thought we were going to do explicit differentiation. I thought I said y cubed, like fuck. Y equals x cubed minus 3x squared plus 3x minus 2.
Topic 3 in section 5.1 has us taking a look at another vocabulary word, critical points. And as it reads here, in calculus, a critical point occurs on a graph wherever the derivative is equal to 0 or wherever the derivative is undefined. Usually this will mean a max or a min on the graph, but it can also mean other things like vertical asymptotes, gaps, or what we call an inflection point. And we're going to take a look at some examples here. The two key phrases that we really need to lock in on here are looking for where the derivative is equal to 0 or looking for where the derivative is undefined. So let's try to keep those two things tucked in the back of our memory as we sort of work through these problems, okay?
With x cubed,
So
there would be
one
one
of this particular function. It's not going to be difficult. All it is a polynomial with a power rule, and I would wind up getting 3x squared minus 6x plus 3. The next thing I'm going to do is attempt to set this equal to 0, because the whole point of this topic is to find these critical values, and of course that was one of the definitions.
Well, one should just plus
wherever your derivative is set equal to 0. I notice that these coefficients are evenly divisible by 3, so I'm going to go ahead and uniformly divide by 3.
Okay, yeah. Then we would get 3 of x squared minus 2x plus 1.
3 across the entire equation, and I wind up getting x squared minus 2x plus 1 is equal to 0. This happens to be a factorable expression, thank goodness, because if it was not...
Wait, you just don't keep the 3 on the outside? My bad. Shit. So we just divide 3 to both sides then. Okay. But now we have to fucking... 100, bro. And then, yeah, x minus 1.
I would need to, reach for the quadratic formula and whatnot. But in this case, the only number that I wind up getting as a critical point is x equals 1. It is important that we also go back and remember that critical points also happen where the derivative is undefined. However, in math, undefined conditions usually happen because you either have a 0 in a denominator or you have a negative under a square root. And we can see here that we're just dealing with polynomial functions. So there's not really going to be any denominators or any square roots that we need to be worried about. So x equals 1 should be the only critical point. Now, how does that show itself on the graph, ladies and gentlemen? I'm going to go ahead.
We can just look at it. So we go to Desmos, 1 second. I should open the fucking differential calculus one. Okay. Womp womp. So we go y is equal to x cubed minus 3x squared plus 3x minus 2. But when x is equal to 1, yeah, the derivative, there would be no slope there. It looks like there would be no slope. So just damn.
And use my calculator to make a quick graph of this original function. I know it's a cubic, so it's probably going to be shaped a little bit like an S. And my calculus tells me that something important is probably happening at x equals 1. So let me take the time to enter this real quick. X cubed minus 3x squared plus 3x minus 2. And when I take a look at the graph on my calculator, it winds up looking pretty much like this. Now, I'm about to introduce us to another new vocabulary word here, at least for the people who are new to calculus. Remember up above, we said that finding places where the derivative equals 0 often happens because you have found either a maximum or a minimum of some sort on the graph. But these conditions can also happen at vertical asymptotes, gaps, or what is known as an inflection point. Now, for the people who have already had calculus AB, you know what an inflection point is, but the rest of us don't really, okay? And notice that what happens right there, hovering below x equals 1, is a split moment on the graph when it flattened out and it received a slope that was equal to 0. It's not technically a max or a min, though, you guys. And we call this, like I said, an inflection point.
Okay, 1 second. The inflection point.
The easiest way to think about it, in my opinion, is the curvature of the graph changes there. So if we were to follow this section of the graph, this looks like a frown, or at least part of the frown. And then if we change over to this side of the graph, this curvature looks more like a smile, or part of a smile. And that's really what we're going to learn inflection points are all about, is where a change in the curvature of the graph, okay? But as far as this topic is concerned, we just know that it is a critical point because it is a place where the derivative was equal to 0. And the type of 0 derivative that was achieved happened to be an inflection point. Let's take a look at another example, ladies and gentlemen. We have a total of 3 in this Roman numeral, by the way. And I think that this next example is really important because it really drives home, in my opinion, the idea of looking where the derivative equals 0, but also taking the time to look where the derivative is undefined. And let's say that the original function that you are given here is 1 over x squared minus 1. And I'm going to go ahead and take a derivative here. We are going to need to use the quotient rule.
Oh, no.
Unless you want to try to use a chain rule, that's okay too. But I'm going to go ahead and use the quotient rule. And I get derivative of the top times regular bottom minus regular top times the derivative of the bottom all over the bottom function squared. Because much of this is multiplied by 0, that section is going to disappear. And we wind up getting negative 2x on top and all over the bottom function squared. Now, this is where the idea of making sure we look where derivatives are zero and where they're undefined comes into play. And we saw this when we were working with implicit differentiation a lot, you guys. In a case where your derivative wound up being a fraction, we need to remember that when a numerator is set equal to zero, that's when the fraction is truly equal to zero. So that's part of what we're going to need to do here. Okay, that's going to find us the true zeros of our derivative.
Oh, okay.
But if your denominator is set equal to zero, that is actually addressing the...
Okay, 1 second.
those undefined conditions that are spoken about, okay? And so if I solve this, I get x equals 0. And if I solve this, I would probably start by taking the square root of both sides. The square root of 0 is just 0. I would add 1 to the other side, and then I would take a square root, and like a very good math student, I'm going to remember that I need my plus minus sign there. Let me go ahead and graph the original function on my calculator so we can make sure to tie in how all of this stuff sort of matches the idea of being a critical value. I actually knew from the beginning of our question here that there were going to be important things happening at both positive and -1 because they happen to be vertical asymptotes of the graph, you guys. I don't even need my calculator for that because I know how to find vertical asymptotes. They come from non-canceling zeros in the denominator. But let me go ahead and enter this into my calculator so I can get a more accurate view of the graph. And it turns out that there's a piece of the graph that goes like this, and another piece of the graph that goes like this, and then there's the third piece of the graph that goes like this. And yes, in fact, we did get two critical values at +1 and -1 in terms of being vertical asymptotes, but we also got that critical value that we found right here in that x equals 0 because you guys will notice that the slope, or in other words, the derivative, happens to be 0 there. So again, the broad scope idea, anytime you're looking for a critical point, is looking for anything critical that might be happening on your graph. And critical things could be vertical asymptotes, they could be maxes or mins, they could be inflection points, but the derivative is a very, very powerful tool to help you do that investigation and to help you do that analysis. Okay, let's take a look at our next example.
Let's go. Another example.
In our next example, the function is going to look like this.
Cubic roots.
And I have a different recommendation for you this time that is not the quotient rule, you guys. And the main reason why is because a cube root means that this thing is really raised to the 1/3 power. And so if you did a quotient rule, you would be inviting yourself into a quotient rule and a weird chain rule at the same time. And I really don't recommend that. So what I'm going to recommend instead is that we rewrite our function one more step, bringing that quantity into the numerator as a -1/3 power. And then now we're not dealing with both a quotient rule and a chain rule. We are dealing with a chain rule only. So yay, we love the chain rule. Here we go with our derivative.
Hold up, bitch. God damn. Y prime would equal, yeah.
Chain rule says drag the exponent down in front, preserve the inside stuff. The new exponent will be 1 less than it used to be, so now it's -4/3. But then we also need to chain on the derivative of the stuff on the inside of the parentheses, which if we use the power rule is -2x.
So
we do need to simplify this a little bit, otherwise we're going to have a lot of difficulty trying to find our zeros and find our undefined conditions. So I recommend that we multiply those two things together, which gives us a total of 2/3 x. I also recommend that we take this section of the equation, because it's raised to a negative power, and move it downstairs so that it will be raised to a positive power. And now I want you guys to notice that we're dealing with that same situation where our final answer was a fraction. So if we want to see where the derivative is equal to 0, it's the numerator that we need to work with. And if we want to know where our derivative is undefined, it's the denominator that we need to work with. So hopefully you guys see sort of a theme showing up here, that really a lot of your derivatives might wind up being fractions. And every time that we are dealt a derivative that's a fraction, we really need to split it up. So you have your numerator equal to 0 and your denominator equal to 0 so that you can solve for all of the potential critical values. In this case, we could divide both sides by 2/3 and we still get 0. In this case, technically what I'm doing is raising both sides to the 3/4 power, which is going to cause that to cancel. But 0 raised to any power is still 0, so it's not that big of a deal. Adding x squared over to the other side, and
1 second. Square, which I mean
then taking a square root with a plus minus sign, we get plus or minus 4 as our final answer there. Now, this particular function, if you scroll back to what we started with, is not really in a family of functions that I am all that familiar with, okay? And you probably aren't either. So I'm going to go ahead and enter it into my calculator and see what the graph looks like. And then for all of the critical values that we got, you know, we'll get to investigate kind of what kind of critical values they were. Were they
Bro, what is this
maxes or
shit?
mins? Were they vertical
Bro, this is shit
asymptotes?
that
What
you
was really
never learn.
happening
I don't
there?
want to hear. It's called
And the
critical
graph
points.
that I am getting on my calculator has vertical asymptotes at 4 and -4. And you guys, it's a very wide looking graph that kind of does something like this and something like this.
Maybe I did learn it. Maybe
and
you
also
did.
something like this. So it turns out that the
But
analysis of
but like the thing is that kind of makes no sense. Is that like I checked. See, I do. Well, I checked Tim's notebook and didn't write down shit. I'm gonna check. I'm gonna check your notebook right now to see if there's anything, if you took down any notes of it. And no, and I know Tim. Like Tim's really good at note taking, unlike you. So like I can't trust your notebook that well. Cause like his ended at like log shit. Basically what I just finished. I was gone that day, bro. You were gone every day. No lie. But Tim was also not there. Natural log, yeah. Curve sketching. But that's it. That's just curve sketching. Like I'm about to go into curve sketching, maybe. But his isn't natural log and shit. Yeah, exactly, bro. I don't want to hear it. Oh nah.
this one is real similar to the example that we just did right before it.
Really?
We have two vertical asymptotes that we are dealing with that definitely count in the realm of critical values.
The curve sketching stuff again. I don't fucking know. Maybe you will see next next topic. I don't fucking know.
And right here at x
It was
equals
dumb
0, this time it happens to be a minimum, but it's definitely a place where your slope,
well, yeah, its slope is
flattened out
0.
and became equal to 0.
Its derivative is 0.
Even though I was not that familiar with this kind of family of graphs, I did kind of have some intuition that something weird was probably going on at plus or minus 4, because that would have caused a 0 in the denominator. I mean, even with the cube root there, it would still cause a 0 in the denominator. So that was something that my brain had sort of thought about before I really dove into doing the derivative analysis on it.
Bro's really talking out here.
We have one more example that we're going to take a look at here. And the function this time is going to be a fun one. Before we really get started on the derivative of
It's a
this,
product rule. It's a
and
product
it's
rule.
supposed to be a multiplication dot, I want us to have a quick conversation about the domain of this function. Because when we are talking about critical values on a function, it also has to fit within the domain of that function.
Dom.
And remember what domain means.
We did this on Sunday, but I had work, so I couldn't do it. What do you mean on Sunday? What? What the fuck? Oh, what?
Is there are going to be some x's that work and can be plugged in, and some x's that don't work to be plugged in, and we have to kind of look at that.
Domain bozo.
I think that the x's that we would have to choose would have to be either 3 or something less than 3, and it has to do with the configuration of the square root there. We know that we can't have negatives under the square root, so let's keep that in mind, okay? I also want, and you should as well, to rewrite this original expression so that
x
this
squared
part
times
is raised to the
3
1/2
minus
power.
x to the 1/2 power.
Unfortunately,
Chain
we
rule instead
do
of product
have
rule.
a product rule on our hands.
That's what Dom
here,
is. Yeah,
but
I
with
know, it's a
chain
joke.
rule kind
Jesus
of
Christ.
embedded
Yeah, I know.
inside of it. So we need to be very careful about the way that we take our derivative here. Let's give it a try.
Okay, I can do it. One fucking second. Y equals 2x times 3 minus x to the power of 1/2. Oh wait, no, did I didn't mean plus x squared times 1/2 3 minus x times 1, which is useless to have. So then we get y prime is equal to that's 6x minus x to the power of 1/2. Fuck it. Plus x squared over 2. I don't fucking know, bro. This is just ugly as hell.
Derivative of the first times the regular second plus the regular first times, and I'm going to put a little underlined section here where I can take the derivative of that second function, which is here, and that's where my chain rule is going to come into play.
Oh shit, no, it would be
So
negative
the
1.
1/2
So it
comes
does
down
matter.
in front, leave the inside stuff
My
alone.
bad.
New power is negative 1/2, and
Forgot
then
about
we
that.
have to chain on the derivative
I
of
always
just
forget
the
about
stuff
that. Like,
on
I
the
know how to do it, I
inside
just
of
want to forget. I always
parentheses,
forget to just do
which
that.
happens to be negative 1. Well, you guys remember that simplifying is really pretty necessary because we're going to need to take our derivative and set it equal to 0 so that we can do some analysis in terms of critical values. So there's a lot of simplification to do here. I do think that we should use this big, huge plus sign to our advantage, though, because it's like a Goldilocks situation. We don't want it to be too hot. We don't want to be too cold. In this case, we want it to be somewhat simplified, but not too simplified. So here I'm going to go 2x times the square root of 3 minus x, and keep the big, huge plus sign, and then really investigate what should I be combining together over here. I can do this guy, and I can do these two
Negative
guys,
x squared.
because
So
that
negative
just becomes
x squared.
negative 1/2 x squared.
Oh, my
And
bad.
then this part that I put an orange box around is raised to a negative exponent. So I should move it back down to its own personalized denominator. Now, I know that there are more things that a person could do to simplify this. Maybe you could get common denominators and stuff.
No.
But again, we want to be a little bit like
Keep change, flip
Goldilocks.
that
We want to
bitch.
simplify just enough, but not too far.
I like the
And I'm
negative
actually
1/2
going to
divided by
leave
3
the
minus x
expression
squared.
like this for the following reason. I want you guys to notice that this fraction right here, as ugly as it is, happens to be negative. So I am going to be adding that really ugly fraction over to the other side of the equal sign, and it turns into positive 1/2 x squared over the square root of 3 minus x. And the reason why that is such a great idea is because I can basically think of...
One sec, I gotta fucking write that note down. That is hella important to know. What the fuck? Man, what I do? It'll be minus... Fucking, what was it? Minus x. So then we get fucking 2x root 3 minus x is equal to 1/2 x squared all over 3 minus x, then listen to the root of.
Like there's a little 1 underneath here, and then I can do some cross multiplying. And you just have to trust me that
Fucking
in the end, it
what?
winds up being way less of a headache than if we would have gone through with full common denominators. So if I cross multiply the first direction, I get 2x times, now square root of 3 minus x times square root of 3 minus x just becomes regular 3 minus x. And then when I cross multiply the other direction, I get 1/2 x squared. And all of a sudden, this expression has really simplified itself down into something pretty reasonable. Let me do a little bit of distributing. 6x minus 2x squared equals 1/2 x squared. Let me also subtract this over to the other side. So I would get 6x minus 2.5, which is the same thing as 5/2 x squared, is equal to 0. I think I want to take out an x as a common term, and then I can set, as we always do with factoring, I can set these two factor blocks equal to 0. And this tells me that x equals 0 is one of my critical values. I need to keep going with the other one just a little bit, adding 5/2 x over to the other side. And how about we multiply by the reciprocal, which is 2/5, and that will allow that to cancel. And it turns out that our final answer for x is something like 12/5. Okay, so I am armed with some very interesting information about this graph, ladies and gentlemen. This is
The
another case where if I
fuck?
look at the original function at the beginning,
What I
I
do,
really
bro?
don't know a lot about that family of curves. I know that the derivative is pretty icky because I had to do a product rule and a chain rule in order to get there, and I had to do some factoring in the end. So let me go ahead and type in the original function on my calculator. X squared times the square root of 3 minus x. And if I have my calculator graph it does look a little bit funny, you guys. The graph looks something like this. It bounds downward, touches off at the origin. Sorry, that doesn't look exactly like the origin, but it should be. And then it kind of, oh no, the calculator or the pen did something funny. Let me try that again. Okay,
Bruh.
it bounds downward towards the origin, and then it kind of just quits.
Damn.
The number that it quits at is not a surprise to us, though, you
Oh, it's
guys.
at 3.
It basically quits at the number 3. And remember, we said that as a domain restriction at the very beginning, that we should not be using any numbers that go beyond 3. So I'm glad that we saw that on the graph. We also see a critical value right there at 0,
Yep.
and a critical value right there at the x value of 12/5. So again, you guys, the derivative is
That's
such
so
a
fucking
powerful,
cool.
powerful tool that really helps us hone in on those most important moments of the graph, things like vertical asymptotes, maximums, minimums, that kind of thing. And if any of us have ever wondered, you know, calculus was developed way back in the 1700s. How did they do all of this stuff without the help of technology? And really, that they were so thrilled to find how powerful the idea of the derivative was, because they were able to take a look at graphs and explore values of things through the use of the derivative.
Bro's really like
Never
me,
needing
bro.
technology.
Just thrilled for math, just fucking fiending for math. Bro really out here fucking fiend. Fuck. Okay, topic number 4. Let's go. Let's go. Come on, we got this. Pick number 4. States critical points. Actually, no, wait, hold up. Hold up. Womp womp. Critical points. And extrema. Extrema on graphs. With sharp cusp. Womp womp. Sharp cusps, absolute value. Absolute value. And piecewise. Okay, and we have our first example as g of x is equal to the absolute value of x minus 1. Womp womp. Come on, bro. Minus to the absolute value of x minus 5 on negative 2 is less than or equal to x when x is less than or equal to 7. Okay, then.
Topic 4 in section 5.1 has us looking at just families of really sort of strange or non-traditional graphs that don't operate well under the derivative. Now, we know just from our past experience in math that absolute value functions especially tend to have a lot of sharp cusps because they're V-shaped, or for some other reason there is a sharp cusp in there. Piecewise functions, that's the last one listed in the title here, are also kind of interesting because if the two parts of the piecewise function don't meet up, then we have all kinds of issues as far as gaps or jumps,
Differentiability and
issues, and that kind of
constancy.
thing.
Yeah.
So how do we deal
Yeah.
with the idea of extrema or critical points in those arenas, okay? And the answer is we kind of have to drift away from the derivative a little bit, you guys, and
Damn.
instead take a look at the graph. Now, this happens to be two graphs that if they were separate, either absolute value x minus 1 or absolute value x minus 5, I would know exactly how to graph them because they would just be a V shape that had been shifted in a certain direction. But when you put the two of them together, okay, you put the two of them together and put a subtraction sign in between them, of course it's not going to turn out that way. And so if you were in the middle of the AP test and you did not have a calculator on you, really the only way that you could tackle this one is by use of a t-table, okay?
Damn.
And if you want to make a t-table, you are more than willing to do that. I went ahead and punched it in on my calculator just so we could kind of take a close look at it. Notice that there is also a domain restriction here, so they really only want you to take a look at the graph from x is -2.
Yeah. 1 fucking seconds. 2, 3, 4, 5, 6, 7.
Over here to x is +7. And I can tell you that this is what the graph looks like. We seem to be consistently down here at a value of -4 until we hover below the number 2. Then it raises in a consistent linear kind of manner until it hits the point 5, 4. So let me actually put some solid values on this graph so you guys can kind of see what's going on. And then it consistently moves in a horizontal kind of line segment for the rest of the life of the graph. If we weren't restricted between -2 and 7, please know that this graph would continue going in a horizontal manner that way and a horizontal manner that way. But of course, since we're just trying to analyze where your critical values are at, we just need to take a look at the segment that they've given us between -2 and 7. Let's really take a deeper dive into the vocabulary of what it means to be a critical point, though, you guys, because critical points are partially defined as either maxes or mins. That alone is really weird on this graph, you guys, because typically maxes are just like the top of a little peak or something, and that doesn't really happen here because the maximum actually occurs consistently from 4 all the way over
So
to 7.
just say relative
So I don't
maximum?
even, you can just say x's that go between 4 and 7 are all sort of tying for being the maximum of this graph. And then the same thing could be said for the minimums. As long as you stay for x values between -2 and +2, all of those values in between and on that interval are all the same minimum values. So they're all kind of behaving as critical points. Critical points also happen, though, when your derivative is undefined. And we have learned in previous chapters that derivatives are undefined at sharp cusps. Please remember the reason why is because the derivative on the left does not match the derivative immediately to the right.
Yeah.
Same thing over here. And there is no smooth transition between the two. Okay, so we could also say that this graph happens to have critical points at x equals 2 and x equals 5 because the derivative is undefined there. The last thing I want to say before we leave this example is once again reiterating that because we're dealing with a lot of absolute values here, we cannot do the analysis for maxes and mins and undefined conditions like we would normally do through the derivative.
Okay, yeah, bet.
So we're really back at relying on the graph again, and the ideas of this whole thing have sort of come full circle, okay? A very similar idea, but different enough, is going to happen in our second example, ladies and gentlemen. And our second example is taking a look at the graph of the absolute value of x squared minus 3x. Now, back in the first chapter of the year, and let me go ahead and give us a little domain restriction there, but in the very first chapter of the year, we reviewed what it takes to graph things like this, especially without the help of our calculator. And also, please understand that we aren't really allowed to take a derivative of this outright because the absolute value symbols sort of prevent us from being able to do that, right? We don't have derivatives for absolute values because in general there are sharp cusps which make them not differentiable. So what we learned or reviewed in the very beginning of the year is what you can do is go ahead and pretend for just a moment that the absolute value symbols aren't there. Maybe you'll do a little bit of factoring and you'll set each of them equal to 0. And basically what I'm doing here is I'm just trying to establish what the graph of the parabola would look like if the absolute value symbols were not there. So the graph of the parabola would look something like this. But of course, our equation is wrapped in absolute value symbols, and we remember that what that does is it turns everything positive. So in other words, any section of the graph that is living in the negative world gets rebounded right back up like that. And then, so the graph that we should be looking at is the graph in orange, okay? Now, just by looking at this visually, I can, oh, and we also want to take a look at the domain restriction on the ends. Sorry about that, you guys. So we want to be right over here at -1, and we also want to be over here at +5. So if I could outline in blue the section of the graph that we're really supposed to be looking at here, okay? Yes, we have some like maximum or minimum behavior going on at the endpoints of the interval. That's always a thing. But as far as trying to define critical points, I could say something like, we have a critical point at x equals 0 and x equals 3 because the derivative is undefined at those two locations. There are sharp cusps at 0 and at 3.
Okay.
But there's another spot, you guys, because remember, critical values also happen when your derivative is equal to 0. And there is a place right there in the middle. We happen to know, you guys, that parabolas are symmetrical. So if this is at 0 and this is at 3, clearly, you know, the other one is going to happen at 1.5. So I can say critical point at x equals 1.5 because the derivative is equal to 0 there. Now, wait a second, because I want you guys to be a little bit troubled by what I've just said there, okay? I have not really been able to take a derivative. So am I sure that the derivative is equal to 0 there? I mean, our common sense tells us that probably
Because,
it is,
probably,
just by the nature
no,
of the symmetry
parabolas.
of parabolas. But really, to get a little
Ouch.
bit more backing here, you guys, mathematical proof, if you will, we can say that the original function kind of sort of generated from this before the absolute value was taken. So if we take a look at the derivative of that, we could use the power rule, set that equal to 0, and the final answer that you get out of that is, in fact, 3 or 1.5. Now, of course, this mathematical reasoning here really finds you this minimum, right, which doesn't even really exist on the absolute value version of the graph, but yet it kind of does because it's a reflection upward anyway, and it's not really going to change the location of the x value. It'll change the y value, but it won't change the location of the x value where your critical point occurs due to the derivative being equal to 0. So please just be aware that that is another technique that you can use when you are dealt absolute value equations like that, is you can sort of pretend for the moment like the absolute value symbols aren't there. Go ahead, take a derivative, set it equal to 0, all that good stuff. And that will at least help you nail down where potential maximums or minimums are at, even though they might need to be flipped up into the positive realm. Okay, the derivative is still useful there. But I think we have our full list of critical values.
Damn.
The last one we're going to take a look at here, ladies and gentlemen, is in the category of the piecewise function.
Fuck.
So let's say the piecewise function, we've got one that happens to be linear. And then we've got another one that happens to be quadratic, okay? And let's see what good of a job we can do trying to graph this bad boy. So 3 minus x, well, that's going to be a linear function that has an intercept at 3 and a slope of down 1 over 1. So the graph would normally do something like this and something like this. We need to be very aware of the domain restriction. This tells us that the graph only exists for x values that are less than 0. So technically there should be like an open circle here traveling this way because it's to the left of the origin where x's are less than 0. So we want to make sure that we are sticking only to the left-hand side and not to the right-hand side. Now let's take a look at the parabola that's been generated here. Let me see if I can factor it. I'm not a huge fan of factoring things when my x value is at the back of the equation, but I suppose that I could try to tough it out. Maybe 3 times 1 would make it work here. Let me check my smiley faces. This would give me negative 1x. This would give me positive 3x. And that is a total of positive 2x, which is exactly what I needed. So yay! Okay, if I were to set each of these guys equal to 0, x equals 3 and x equals negative 1 wind up being my final answers. So let me just sort of sketch what that can potentially do for me. I'm dealing with a parabola here that I know has, but it has a negative leading coefficient on it, you guys. So it would actually be a frowning parabola. Oh my goodness, I was almost fired. Okay, so the graph is kind of sort of doing something like this, okay? And remember, when we're dealing in the calculus world, whether or not these piecewise functions connect is really what's most important to us. And so I really need to get a handle on what is happening right here at x equals 0. And if I go ahead and plug in 0 to this function, I would get 3 plus 2 times 0 minus 0 squared, which is, in fact, a final answer of 3. That's
Oh,
really kind of nice,
sheesh.
ladies and gentlemen. So when I sketched in the parabola, I should have sketched it to have a slightly higher trajectory, but of course I didn't really know that at the time because I was just making a sketch, okay? But now that I've plugged in a solid point, I definitely know that I need to, and it's going to be more on an upward trajectory
Oh,
like
yeah.
that, and I do want to make sure that it still crosses through the other x-intercept over at x equals 3. And again, this parabola is good for x's that are greater than or equal to 0,
Okay.
so it's going to exist on the right-hand side of the y-axis. Now, last question. What kind of critical points are we working with here? Critical points, okay? Well, in the category of the derivative being undefined, I think that we see one of those at x equals 0 because there is a
Well, yeah.
sharp cusp there. But in the category of the derivative being equal to 0, I think we see it in the upside down peak of the parabola that we have here. And of course, I can make a guess where I think that's at. I think it's at x equals 1. But the best thing to do is actually just to take a derivative of your parabola really quickly. And if I use the power rule on that, I would get 2 minus 2x, set it equal to 0, solve it out really quickly.
Damn.
And yes, in fact, the derivative is equal to 0 at an x value equal to 1. So not only did that match visually, but it also matched when we backed it up through the use of the derivative. I do not think that this graph has any other critical points. So I think that this completes our analysis for this topic.
Damn, okay. Sheesh. Uh. Oh, fucking this one. I hated this fucking story problem in pre-calculus, dude. This shit was hella annoying. Topic number 5. Story problem. Oh, just a fucking story problem. You know how it goes. I fucking hate this one. Open top box. It's to be made. It's made from an 8 by 12 flat piece of cardboard. Cardboard by cutting out x by x squares. Squares from each corner. Yeah. And fold it up the sides. The sides. Ah, bro. Find a model for the volume. Ah, damn. Of the box. Then use calculus to find the value of x that would maximize over volume. volume of the box. Jesus Christ.
Time for our final topic in section 5.1, and it is one story problem. Not just one story problem, ladies and
Fuck.
gentlemen, but the infamous open top box question. Okay, and for those of us who have always sort of memorized this formula but never really understood it, I implore you to listen a little bit to the explanation today and really try to latch on to the idea of the volume of this box and where it comes from, okay?
Okay.
So we are starting with a flat piece of cardboard that is 8 by 12, and I'm going to go ahead and draw a picture of that. 8 by 12. We're going to come along with some scissors. Sorry, I have the hiccups. I don't know why. We're going to come along with some scissors, and we're going to cut out little squares. We don't know how big they are, but we know that they're all the same in all 4 of the corners, ladies and gentlemen. So I'm going to go ahead and label them all as being X by X. You wouldn't want them to be different sizes, and your box would be terribly lopsided, and it would not really fold very well. So I literally come along with a pair of scissors, and I cut those corners out. And the piece of cardboard that I have now looks more like this, okay? Because those corners are gone. And remember, the corners were X by X in size. So imagine that there are these dotted lines, these sort of perforated edges that we will fold, and every single one of them will be folded up out of the paper at us here, and then we'll get some tape, and we'll tape together the corners, and voila, what we would wind up having is a box. It does not have a lid, ladies and gentlemen. It does not have a lid, but it is a box nonetheless, and it would look something like this, okay? And that's how it comes to be, by using tape on all of the corners. Now, what we need to do is a mathematical investigation of the volume. And I ask that we start with the most generalized formula for volume of any box in the universe, which happens to be length times width times height. And we need to come up with expressions that represent each of these one at a time, okay? So let's just...
Let me just do it like the mathematician. Just gonna hold up. Let me do the fancy L. 1 second. The fuck? How do you just do that? Just gonna womp womp. Oh, that's an awful one. Times width times heights.
Just talk about the length for a second. On the original flat piece of cardboard, the length happened to be 12, okay? But what happened was an X got cut off and an X got cut off, and those sides got folded up.
So
So it's
12x
not
squared?
as long as 12 anymore. It has lost 2 X's on both sides, and that's why we say that the length can be represented by 12 minus 2X. Similarly, let me change to a different color. The width of this used to be 8, but it's lost some because it's cut out this and it cut out that and then it folded it off.
Okay, so then
So it's 8, but it has
minus
lost an
2x.
X on each side. So 8 minus 2X. The last dimension, and probably the most important dimension, and the dimension that I have noticed students often forget to put on their equation, happens to be the height of the box. And if you think especially about this diagram here in the upper right, once you fold those tabs upward, the height of the box becomes the X, because that was how, the measurement of the little tab there. So the height of the box becomes X. Now, in the past, you guys probably maybe entered this into a graphing calculator and adjusted your window until you could find the maximum, because we're looking for the value of X that will maximize this. Well, we're not going to do that anymore, ladies and gentlemen. We are in calculus, and we have the power of this beautiful thing called the derivative. So let's see what kind of magic the derivative can do for us. Of course, I do need to FOIL all of this together first.
Oh.
So I'm going to get 96, and I'm going to get minus 24x, and minus 16x, and positive 4x squared. If I combine like terms between these two things, now I would have 96 minus 40x plus 4x squared. And then I'm finally going to distribute through the final x. And when I do that, I'm also going to be very detail-oriented here, and I'm going to put my polynomial into what they call standard form. So it starts with the highest exponent.
Just fucking power rule
its way
that
down.
bitch.
Now, when we do story problems in calculus, we need to be very careful and very, very sensitive to have we
bad.
actually taken the derivative yet, or is this just still the setup of the original equation? And I
Still the
think
original
that
equation.
this is just still the setup, right? We did
Yeah.
length times width times height, we foiled it all together and everything, but we have not yet actually taken the derivative. So yay, cheers for the derivative. And we could just use the power rule here. It becomes 12x squared minus 80x plus 96. And we know, okay, so there are a few things here that we know, actually, you guys. Just by
Fuck. God damn it.
the way this final equation was written, it is a cubic of some sort. And the nature of a cubic is it's going to be shaped something like this. And yes, that cubic is going to have a maximum value somewhere along the way, and that's what we are after. That is what our derivative is essentially helping us to find. I don't know if this factors. These numbers are awfully big for me to try to factor it in my head. I do think that each of those coefficients are divisible by 4, however, so I think it is totally worth my time to kind of reduce it down a little bit. Oh my goodness, what is 96 divided by 4? You guys, I should be smarter than this. 24 is equal to 0, okay? And so those numbers are a little easier to work with. However, I don't think that it factors, you guys. And I've noticed
Quadratic
that
formula.
when we do the folded box question in calculus, it pretty much, the final answer, like, never factors. So you pretty much have to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. And let me kind of figure out what we would have left under the root here. 400 minus 4 times 3 times 24 gives me 112 left underneath my root.
Damn.
And it looks like I have a total of 6 down in the denominator. Now, there is some additional simplification that I could do here, but I'm dealing with a box of a physical dimension, so I think it's okay if I go ahead and plug this in on my calculator and just get a decimal. All divided by 6. So when I use the plus option, my calculator tells me 5.097. And if I use the minus option, my calculator tells me 1.569, okay? And the thing of it is, you guys, since both of these final answers happen to be positive, I suppose that potentially both of them could work to get us the value of the maximum volume. However, we need to bring more of our common sense with us. So let me take those values back up to the original diagram that we drew, 5.097, or 1.569. And what I need to remember here is that these are potentially the size of the squares that are going to be cut out of these corners, okay? And if I think about it, I think that the 5.097 is too big. Because if I were to cut out 5.097 this way and 5.097 that way, that's more than 10. And the original side of that box was only 8 to start with, okay? So in math, this is what we call an extraneous solution, you guys.
Hey,
That one is
fucking
too
what?
big to accommodate the original dimensions of the cardboard. And that tells you that this one is the extraneous solution, and thus what we should do is cut out 1.569. Let's just take one quick look here at how that would actually affect the volume, because remember, volume is a matter of length times width times height. And the way that we put those together is the length was 12 minus 2x, and the width was 8 minus 2x, and the height itself was x. So if I want to know the length of the box once it's folded, I need to figure out 12 minus 2 times 1.569. And if I want to know the height, I'm going to go with 8 minus 2 times 1.569. I'm sorry, that's the width. Apologies, that's the width. The height is really the easiest one of all, because we know that the height was just whatever the value of x was. So in this case, 1.569. Let me use my calculator here real quick to get the final answer on this. 8.862 would be your final length. and 4.862 would be the final width. So if we want to know the final volume of this particular box, we could take length times width times height. And this will be our final computation for this question, ladies and gentlemen.
And how long you gonna be doing calculus, bro? This is the final
My
one,
calculator
bro.
gets somewhere around 67.6, and that would be in cubic. I don't know if it was in inches or meters or whatever it was.
Cubic
Let's just
inches.
assume that it was in inches, okay? But that's how we take a look at the folded box question through the lens of the derivative.
Fuck that. I always hate that shit. Okay. I hate the full box question. I was dumb as hell doing that shit, bro. Okay. Well, time to do Borderlands now since you keep complaining and shit, bro. Uh. Can I update my settings on Streamlabs? Oh, I can. Let's go. uh, Borderlands 3. Technically, I think day 5 of playing it. Yeah, public category. I can't change the category? Fuck off. Fuck off. I can't change the category. God damn it. Close enough. Bro, that was 90 minutes. God damn, bro. Shit. Fuck. Shit. My bad. Yo, Monty, are you ready now? Are you fucking ready for some Borderlands 3 gameplay that's gonna be like 40 FPS? Bro, my AC unit is so powerful, it's shaking my fucking light. Okay then. Oh, what the fuck? I think my max FPS limit is like 40. I think that's my absolute maximum. Game's a little loud, I think, personally. Damn, a little bit. Okay. Finally, dude, we be gaming. My ears. And there's fucking Claptrap. This little bitch boy. This little bitch boy. Oh, bruh. Bro, my god, this game takes fucking forever sometimes, bruh. Oh. Those games made the Unreal Engine, that makes sense. Bro, they really made something on a fucking free ass engine. Big ass company, bro, out here. Yeah, my FPS limit is literally 40, dude. Jesus. My critical points. My bad. Bro, I have everything on literally low and shit, bro. Okay. Uh, should be on tab. No. Log. Guess I'm doing that one.
This thing on? Test, test. Hey,
Axton, let's go.
mother! Have we got an opportunity for
That's
you?
awesome.
You don't want to miss it!
Yo, it's the original team. Let's go. Hog. Can I go this way? No. Damn. Okay then. Go up here. Hey, Hog. Let's go. Okay then. Money. I do like that. Okay, so no then. So it's gonna be like over here. Or I can just do it that way. Yeah. That works.
Dang
Yeah.
it, soggy biscuits again. Sorry, guys. Larry's brunch is canceled this week. Maurice has seen this before. You will add eggs from the Eunomian time wasp to the batter. The biscuits will emerge from the kiln, fluffy and buttery. Wow, thanks, Maurice. You're the best. Hey, everyone. Maurice saved Larry's brunch. No, no, no. This is all wrong. Maurice is a Saurian, a cold-blooded killer. He's got to be up to something.
What? Okay then. Huh. So I go all the way down here. Then, aha. Okay, then. I don't know, bro.
Where is it? My signed copy of Digby Bemoof's best album, Sex to Grind! Oh no, I can't have lost it!
What is
Maurice
the
found
point of
it
this,
in
bro?
Claptrap's closet. He was attempting to sell it on the Echo Net. You will hide it better next time.
OMJ, I can't believe you got it back! And the signature's intact! Maurice, you're my favorite!
I can't wrap my head around this. He's just so...
Oh, fuck, my bad. Wait, okay, what the fuck? There we go, Jesus fucking Christ. Yellow or orange. There we go.
I have to think, Vault Hunter. Give me a moment. Vault Hunter, Maurice has smelled your investigation.
What the hell? Oh, hell
You
no.
will come to Maurice and chat.
Man, I gotta go chat. I'm anti-social as hell. I don't want to do that. Don't have any golden keys. Kind of sad about that. But that's okay.
Oi!
Very peeing in this game.
Warmonger Marcus has distrust for Maurice. This is understandable. Maurice is on a mission of peace, and this is a threat to business. You will bring to Marcus a gift. Warm blood gift-giving rituals remain mysterious. Where he comes from, Maurice would simply vomit blood on his... Yes. The perfect gift for Warmonger Marcus. You will take it to him.
Okay. Oh, it's below me. Oops. Come on. There we go, Pog. My bad, shit. My bad, Shotty. Damn. Womp womp.
Don't shoot! I mean,
Calm down.
what is this?
Yeah, I'm
A
broke.
present from Maurice? Ah, look at the fumes coming off of that box. Get it away! Put it over there!
Shit, my bad, Shotty.
Ha! I knew it. That present must have a neurotoxin inside. Or some kind of acid that would melt my face off.
Oh, sniper
Maurice
time.
tried to kill me. I knew he was up to no good.
My bad.
What a relief. The last thing I could stand is to have someone nice on board. Ugh. This place only holds together because we all might kill each other at a moment's notice. Thanks for investigating, Vault Hunter.
You're welcome.
A face-melting success.
What?
Warmonger Marcus only respects strength and fears warmth. Though Maurice is here in peace, he knows well the diplomacy of the Claw. You will know Maurice's appreciation.
Oh, okay. Sheesh. Oh, that's good at. This that's actually good SMG. Oh shit! Wait, what?
Make like one of my checks.
I can try to deal with that. I can try that. Yeah. Okay. Now it looks like there's an actual quest, not DLC quest for once. So we go over here. Hey, yo, shit, Shotty, what up? Tannis is running low on health hypos, so we need to start recycling. Search the ship and find used hypos for her. Bet, Shotty.
I'm running short on syringes. It would appear that the idiotic primate inhabitants of this vessel have been stealing my syringes and using them for who knows what. I'm running low and I need them back.
Shit, okay, bet.
Now, how in the hell did that even get up there?
Fuck if I know, Shotty. Damn. Leave me alone. Which one's
Do
the
these Neanderthals not understand that I need to keep this laboratory stocked in order to do my job? Without syringes, how am I supposed to move various liquids from one place to another? Unbelievable.
Man, why you complaining about this shit, bruh? Need to go down here then. Oh, excuse me. Am I blind or something? Oh, I'm saying I literally am blind, bro. So we can get through there.
Why
Okay
are we
then.
still picking up transmissions through antennae anyway? It's barbaric. We live in the future, damn it.
Recruit, you're just in time. I'm about to install this core and speech processor I found to turn on my new claptrap robot friend. And by turn on, I mean power.
I want to fucking day. I hate Claptrap. He's a.
Not to be alone anymore.
Good morning, Grand Archivist. Oh, you startled me, Bot. You're rather quiet on your feet for an indexing unit.
Greetings! I am a VR0N1CA telecommunications bot, but you can just call me Veronica.
Wait,
Shit, Veronica, you sound
a V/Slash
hot.
communications bot? I thought your model was discontinued by Hyperion after the runaway success of Echo 1. That means you're the last of your kind. Like me.
Nice to meet you too!
Recruit, you've got to find more parts for Veronica. She's special, and by special I mean
God.
there's no one else like her, and she deserves the best salvage we could pry out.
Bros down. Bad like me. God damn. What a simp. I can see that because I'm on Twitch. Haha.
You found it where? Unbelievable. That's probably all you're going to find. Please bring them back to me so I may continue my work, Vault Hunter.
Yes.
Honestly, I wonder sometimes why I put up with all of this. Though I suppose it does provide me
Nick,
with
hey,
access
love.
to
Hey,
archives
Murphy. Hello, how are you?
supply of test
Welcome to the
subjects.
stream. Thank you for coming to the stream. How are you?
I suppose to call them
Well, I already
patients.
know how you're doing. My bad. Shit. Listen, I need to look good on stream, okay? So,
Finally, someone who looks like they could take a bullet.
the fuck is that supposed
I
to
can
mean?
finally get back to work now. Thank you, Vault Hunter. And if you discover anyone else has stolen my syringes, please execute them. Okay? Bye.
I'm horrible. Yeah, I'm sorry to hear that. I'm sorry about that. You know me, doing awful.
Get a load of me!
Okay, so wait, whenever Zane swaps with this clone, his charge. Ooh, yeah, I forgot about that. Okay, wait. Wait, no, one's. So clock and little and weird thing. Oh, okay. That's really important. Fuck. Yep, we stand that. Yep. Time thing. Oh, that's all the way down that. Fuck that. Uh. So rabbit and stopping bullets. 1 second. Okay, okay. So the stopping bullets is all the way down there. What was the other one? Fuck. 1 second. I'm trying my best over here. Wait, what? It's oh, oh, I'm fucking slow. Oh, and then the weird rabbit one. Fuck. Damn. G2 ass. Yeah. That's how it'll be though. Okay, so I'm gonna fuck. Need to add a point to that. Then maybe I can start adding points into this because this one's actually good. Damn. Okay. Um, L is for log. Damn. I can leave the main mission. Oh, it's Pickleman. Hey, Pickleman. Just calling out Pickleman like that. Damn. Level 16. Oh yeah. There's my mouse. Oh, I'm dumb as hell. This guy. Damn. Sup. This guy. Damn, you just took an L, Murphy. How do you feel?
Palawan again. These guys are relentless.
Well, yeah, it's Mellow
Drop
one.
pod's ready when you are, VH.
Okay, I will. God damn, leave me alone. Shit, shoddy. Huh? Oh, I gotta go even further down? God damn. Basically, Monty's a mod, or as you call him, Salty Pickle Man. Pickle Man. What L?
A bandit cult led by a soul-sucking siren.
Your fucking message got deleted, lol. Because, yeah. That's why. Yeah. I don't fucking know. I don't know. I'll be chilling. Playing some good ass game. Oh, and that's an L? God damn, my phone charged fast. The fuck are those? What are those? Actually, though, what the fuck? I'm scared. Meet Maya. God damn it. This.
You're here. Right in time for a fight.
What's the point
I'm
of being
Maya.
back here?
Come find me in the market quarter. A battalion of Malawan troops are trampling my home, and I'd appreciate some help. You know, killing them.
Okay, I don't really care. It's not Ellie here. Ah, damn. Okay, well then, I don't know. Fuck, I don't know, bro. Actually, I wonder. I don't care what the fucking vents. Can't I get, like, XP for doing, like, so much, like, X damage? And stuff? Oh, I'm making bank now. Yeah, I can't... Yeah, isn't that, like... Oh, wait, no, that's just zone What? Okay, then. Damn, really nothing. $27. Oh, my God. I can gamble so much for $27. Even though gambling costs, like...
It'll be nice to have someone else here
1.5K.
besides my apprentice who hasn't taken an oath of non-violence. Speaking of which,
Bro got fucking folded.
see you soon.
I forgot my keys. Oh yeah, it's like F. Oh yeah, F and G. There we go. I just remember some of my keys. That's all. God damn! Yeah, this gun is so much better. The fuck is this, bro? Oh, nah. There we go. Oh, badass. Oh, no.
Just laying out some
Oh, wait, yeah. What if I do the
karmic realignment.
Yeah, the shotgun's really good. Oh my god, it's that good? Damn!
You and bullets for you. Everybody gets bullets.
But I'm not good with it, but that's okay. Money. No, I'm not gonna use that. I need to just make sure everything's reloaded. And to be honest, like, that's not really good. Oh, 8%? Oh, nah, bro, I'm good. Oh, I did. Ah, fuck. Unless I did keep it? Did I keep it? Oh, I did. Okay, yeah, good. That was smart of me to keep it and shit. Just, just do the simple. Oh, you fucking bitch. Yeah, take that.
Are you
There we go.
serious? Open your bloody eyes.
Okay, shit, my bad, shit. Do I have that reloaded? I do. Okay, good. Wait, what do you mean there's something, like, over there? Like, the fuck you mean, game? God, there's a lot of good shit, actually. What? What's over there? Oh, fuck off. Fuck off. Aw, man. Fuck it. Okay, I'm just gonna continue now. Man, what they do? Aw, damn. Man, what a loser. Phase lock and load. Yeah, phase lock is overpowered, especially in Borderlands 2. There you go. This was fixing my eraser. Womp womp. Hey, yo, what up?
So you're kicking ass with the Raiders. Guess Lilith had to replace me eventually. Ready for more action?
I was born kicking ass, and I'll die kicking ass.
Thought so. Follow me. We'll meet up with my apprentice. If she hasn't gotten herself killed.
Okay.
The fragment's sealed inside an Iridian anchor hold. The whole monastery was built around it by monks who think it's sacred. Maybe it is, but right now, it's attracting the wrong kind of attention.
Okay.
I came back from Pandora to protect this place.
Why is that
It was
locked?
working out pretty good until Malawan found us.
Boo fucking who?
Attention,
God, take
stupid
forever.
pacifist monks. This is Oppressor Trot. It's not just a title. Oppression is my profession.
Wait, what?
Apprentice is
That's not
nothing but
okay.
the Malawan Corporation. No trespassing.
What? What do you mean a
Ugh, that's Trant. Real pain in my ass. So far, he hasn't been able to get into the anchor hold, but let's not rely on his incompetence.
Now, look, monks, I know you think I'm doing this because I enjoy terrorizing you, but it's actually to make my big brother proud of me. He's a general, you see, and I got a huge inferiority complex about it. So if I have to burn down your entire monastery to impress him, then so be it, you know? You get it, right? You get it.
What the fuck? Are you gonna, like, die, bro? I need, like, your loot and shit. Ah, fuck, it's an icebreaker. I hate the heavies. Bro, they don't drop any loot? Damn. I'm really sad about that. Aw, you motherfucker. You bitch ass, bro. My kill streak? Oh nah, bro. Oh nah. You don't need that. Get out of here, bro. You definitely do not need that at all. I'm telling you. Killstreak IRL is useless in today's society. Are you gonna fucking die? Thank you. Jesus, dude. What does that actually do? Like, oh, you do get XP and money. Okay. So it's really good to do challenges, actually. Damn. Yeah, okay, okay. Fuck you, bitch. Fuck you. Fuck off. Reload, please. I hate these heavies. Bro, fuck off. Fuck off, fuck off, fuck off. There we go. Gonna explode a little. Just, dude, this is so much shit. There we go.
Coast's clear. When we're not at war, the bells of peace ring all hours of the day.
Can I?
and night.
Damn.
Nightmare, honestly.
Mining
Not
away.
getting through that.
Damn, okay. It was worth a try at least. Give me my ammo, por favor. Nothing. Come on, bro. Give me some good shit, please.
Hiya, where's
I'm
the little one?
begging you.
Probably finding trouble.
Finding trouble, or causing it. May the six storms protect you.
Ugh, he's right. I should check on my apprentice. Ava, are you still guarding the library?
Maya! Hey! Yes, I am definitely at the library. Because you told me to stay there. Here? Because it's where I still am. That was a book. Gotta go by.
What the fuck kind of
Keeping
book
Ava
is
in
that,
one
bro?
place is like holding on to Quicksilver. But that's why I took her in. Either she was going to get herself killed, or maybe I could train her to, you know, survive.
Attention!
Okay then.
Monks of Athenas! Captain Trot!
What the fuck?
Surrender the vault key fragment immediately. We're gonna downsize your stupidly serene planet. That means we're gonna blow it up. God, I love this company.
Don't think-
Form and function.
Don't think it's illegal, but okay then. Ah, shit. Pyrotech heavy bet.
Nerd!
Man!
So hard, he died! What a freaking nerd!
I'm being called out for real, bro.
Oh, good, a poetry module. That makes me feel good.
I'm getting bullied IRL. Damn. Really saying that type of shit towards me. I'm actually offended.
Now entering the clone zone.
Bro, fuck off. Fuck off.
86 those pricks.
Damn, bro. Need more pistol ammo. Shit. Damn. That should kill them. And it did, because I'm goated like that. You know me. Shit, let's go. There's more shit from here. I need ammo.
Hell yeah, Vault Hunter. If you'd been
Damn.
around when the invasion started, we just might have held our own. Now ring the bell.
Really? Okay, bet. Shit, shoddy. Let's go. Okay
You're
then.
gonna need some iridium to get into the anchor hold.
Oh, you're acting like I'm rich.
On an extremely
Iridium.
related note, how do you feel about grave robbing?
I'm for it.
Good.
There's some iridium hidden in the cemetery. Something tells me Ava's already there. She'll help you out.
I've never actually been inside the anchor hold. It's got iridium protections around it, but
Oh.
I think I can get around them. There's a passage in my book of
Okay,
ancient silent
then.
techniques. Gonna go grab it, since the library's unprotected, and I'll catch up with you later.
Okay. Okay then. Very interesting. So we can go grave robbing apparently. Maybe not. I don't fucking know. Hopefully not, because I feel like that's kind of illegal. But that's okay. Just in case. I did not mean to do. Wait, I pressed E. I E's. That's okay. Don't care. Don't care. Don't care. Don't care. Okay then. What is this over here?
Just check that out.
Yeah, okay, so I just gotta take a hard right after I turn, right? Okay, bet. Let's go. Easy W. You know this is gonna be a fight with like this kind of bullshit.
On the house.
Get the fuck out of here, bro.
I call this a successful operation.
Bitch ass fucking ratch. Man, fuck out of here, bro. Fucking hate ratches, bro. Ratches aren't bitches, bro. Ratches be bitching all the time, I'm telling you. Just give me all the fucking shit, bro. Dude, I get so much shit. Like it's actually like dog water. How bad it is. So we go, boop, boop. Womp womp. What, bro? What? That was dog shit, bro. That ain't worth my time. Oh nah, diggity dog. Just oh nah. I don't think so at all. That is kind of true. I really don't think half the time. Bitch ass, fucking rat ass. Bro, oh my god, stop being a cannibal, you fucking weirdo. Okay, actually though.
For a barrier. It's possible you picked the wrong battle.
Fuck! Okay then. Actually... something more. Bro, move, fuck. Get fucking dumped on, kid. You're actually dog water, lol. I just need more fucking shit, god damn, bro. Okay then. I'm gonna see what's back here then, just in case. Because there could be some good loots and stuff. Maybe. I don't know, maybe a fight. I don't fucking know. Let's just see. Oh, there's actually side quest. Big brain. And there's some shit over here. Long ponderous assistance.
It's done. It's done, and there's no going back.
There's an infestation in the... Oh, okay, that's easy.
You must come quickly. The holy distillery is infested.
27...
This way. Thank the six storms, my prayers are answered. I am Brother Mendel of the impending storm, sworn to an oath of non-violence.
Okay.
So, I must beg your assistance with these ferocious
Okay.
rats. You must eradicate them for me. There we are. Now, inside, quickly, before the rats completely infest this holy place.
Okay, then. I'm kind of scared, bruh. But okay.
Ah, that's Ratchgunk. Our distilled spirit should be strong enough to melt such things. Shoot the nearby cask and be rid of that foul infestation. I would handle this myself if it weren't for my oath. Believe it or not.
Actually,
I'm
fuck it.
forbidden from even slapping a mosquito that bites me. Woe is me for choosing the non-violent path. So, you must slaughter in my stead.
There we go.
Righteous gunslinger. How I envy you, Vault Hunter. Unencumbered by the oath, unchained by morality, hunt down those foul
Fuck, I didn't even
wretches
press that.
and rip the still beating hearts from their wretched thoraxes.
Okay, calm down there, bud. Jesus Christ.
Wait, wait! Disembowel them, my divine murderer! Splay their guts on the ground like intestinal confetti!
Intestinal confetti? What the fuck, bro?
Sure.
Oh, wait, it's my little drone buddy. What? Wait, what? I don't fucking know. Okay then. Oh my god, dude, nope. Oh shit, bet. Just get fucking meleeed, bruh. There we go. Oh, probably harvest intoxicated ratch livers. I don't know what the fuck that is. And I'm perfectly okay with not doing that at all. All I need is kill one more brood mother and I'm fine.
A righteous
Easy.
slaughter! Now you must find the final rat hive and put an end to this infestation! Go, my blood-drenched champion, go!
I am
Massacre
not a
beckons!
champ. What the fuck, man? I don't fucking know.
Glorious! Send that beast screaming into the void!
There we go.
Split its skull and drench this holy place in monstrous blood! Where? The suffering is intoxicating!
Okay then. Actually, shit, what I should do. That. Cannot fucking see. God damn, bro. Yeah, no. I'm gonna have to just do that. There we go.
That rat liver seems to be perfectly pickled for our purposes.
Fuck. Okay then. What the fuck? Okay then. I don't think I thought.
Oof. Sort of got caught up in the moment. Thanks the 6 storms you came along when you did. When the Maliwan scourge is driven away, we will toast your divine bloodshed. Grab that clapper and ring the bell of inebriation to summon me when you are ready. A reward is in order.
Oh. Fuck. Wrong key. Shit.
When we monks take the oath of non-violence,
Womp
we
womp.
must relinquish all our worldly weapons.
They are stored nearby, and I urge you to take whatever you need from our weapon depository, my vivisecting avenger. Then return to me.
Damn, that's really nothing, bro.
I admit I am conflicted by my part in your unhinged pursuit of violence. Yet
My bad.
perhaps such transgressions are themselves the will of the storms. You have given me much to ponder, Vault Hunter, and much to think. Salut. Truly, this is the happiest of hours.
The fuck is that? Okay. We got a cool shield. Where is it? Give it to me straight. I don't know what kind of ability that does, but okay then. What's the point of this being over here? Literally nothing. Okay then. Then what's the point? Damn, my bad shit, game. My bad. Then what's the point of, like, this kind of stuff being over here then?
Greetings, Vault Hunter. I am Sir Hammerlock, and I require you to hunt and kill things for me. You see, the Borderlands are full of rare and dangerous specimens. I will pay you top dollar for their trophies. Legend speaks of the blood-drinking chupacabratch. End its sanguine feast.
Okay then, that's awesome. Damn, this game is really awesome. Womp womp. Damn, bro, almost 10 grand. Sheesh. Pretty nice. So I need to get up there somehow. But also, like, just no, I the route that to the fucking right. Oh, it's gonna be Ava. That's cool.
Cool if I take this. Thanks, later.
Aspiring Vault Hunter. Shit. Okay then.
Oh, hey. I was just out here looting corpses. But wait,
God damn, you
you're
were
a vault
short
hunter
as
like mine
fuck,
used to
dude.
be? Go on adventures, save the universe, kill bad guys.
You're making me sound awesome. I like it.
Yes! That's so freaking cool. I want to die instantly. I'm gonna be a vault hunter too. Or I would be if Maya assigned me more than just guarding a dusty-ass library and staring at water for like 100 hours. Sorry, just really boring around here. So, you're gonna loot this graveyard or what? What you got, Gate? Nothing, bitch! You got nothing! Come on.
Okay then.
Oh, crap!
Attention, everyone! This is Captain Trant. Those monks are in that spooky graveyard. Wipe them out, make me proud. Then
Oh, I leveled up already? Shit. Okay, bet.
codes up.
Okay. No, actually, what I do need to do. No. Okay, hold up. Okay. Okay. I'm actually good at video games. Let's go. Pog. No lie. Let's go. Wait, what? Whenever Zane kills an enemy, yeah, okay. Oh shit. I think I just need to buy this. There we go.
Trant,
What makes you good at video games, though, Monty? What makes you so goated? Hi. Hey, Chapstick. Hey, welcome to the stream. Thank you for coming to the stream. How are you? I appreciate it. Thank you. I appreciate a lot. Fuck! I appreciate it that she comes to my stream. There we go. Fuck. I just ended my stream. Hey, Pog! How did it go, then? How did the stream go? I won. Pog, what game? What game, Monty?
Maya says the
I'm
monks
good.
are
I'm
really
glad
cute.
she's doing good. That is,
That
I'm very glad to hear
much
that.
afterlife.
Very
We'll tell
glad to
you
hear that.
later. Like, if we're not also dead.
Womp womp. Shush. Okay. Oh, let's go! Even though I won't be able to book anything because my inventory is full as fuck. Shit. It's all just shit. Mobile game. What mobile game, Monty? God damn! I swear, sometimes I just don't want to talk to you because that's all you fucking do. Just tell me what game I like Critical Ops, that Madden game. Fuck. I get details and shit like you fucking worse than any dry texture I fucking know. Shit. My bad, Monty. My bad. It went good. I don't think I got any new viewers, but I haven't checked it. Oh, but that's fine. You don't need always new viewers. It's nice to just talk to some friends, some old viewers. It's fine. But I'm glad to hear that your stream was good. Very glad to hear that.
But I know a few more places.
That's awesome. I mean, yeah, you're right. I did a drama stream. Oh, Pog! That was awesome. I wish I checked it out maybe for a few minutes or something to try and support you or anything like that.
back. Anyway, I mean, I thought you were supposed
And
to
see
be
your
on
very
that
awesome
shit.
creations.
Stop this rebellion immediately, or I'll reduce your tranquil meditation plan to
My fault. Oh, gee. I mean, yeah. But I mean, shit, dude. Like I'm trying to talk at you, and you're saying fucking nothing to me. Like, bro, fuck, I'm trying so hard. Cause I'm a caring person, and you're making it fucking difficult. Cause I'm like, damn, bro. Fuck. I streamed for an hour and a half. Okay, nice. That's awesome. I'm glad to hear that. Doing some nice, good old streams. Fuck off, fuck off.
Let that be a lesson to you.
The fuck? Okay then. Hee har. We need more money, god
I
damn it.
got this one. Ah, it's
You
sticky.
do?
Why? Why is it sticky? Oh, monks are so weird.
Bro, this fool is 0 1 26 launches. Bro, I see shit on them. Bro, why are you talking about my fucking record like that in chess?
The graveyard. That's where it went down. See, I was admiring the tombs when Siren Queen Dido catches me. You must die, trespasser, she says. Any
Nick,
final
me and you got a
requests?
battle in this game. What fucking game? Holy shit, Monty! I've asked you this 30 times! What fucking game?
Takes my hand. I remember her gray hair cut by the moonlight, and how her bony fingers grabbed my tuchus and wouldn't let go. Next thing I knew, she smooches me right on the tomb.
The fuck?
Boom! Siren girlfriend.
The fuck? Okay then, let's see how good this goes. Sorry, we're closed. Burley said we're closed at a fucking gravesite. That's the truth. Really bad migraine. I thought I wouldn't be able to stream, but I did. Hey, I'm glad to hear that you stream, but I'm sorry to hear that you had a migraine. That sucks a lot.
I hate rats! Or is it rats? They must die. Huh. Looks like they ate the iridium. But Maya's gonna need way more than that. Last tomb. Then we can go get that fragment. Man, I've been dying to get inside that anchor hold ever since I got here.
Okay.
Something about locked doors, man. It's the home.
Rats attack! Run! This wasn't in my contract.
Okay then.
Big ratch! Big freaking ratch!
It's a little bit of a big ratch, not gonna lie.
Aw, hell yeah! That iridium!
It's probably covered.
Shut the fuck up, please, bro. I really do not care.
Did that one have a bounty? Did anyone teach you how to fight?
Bro, this delay sucks.
Ugh, let's get this iridium to Maya.
How are you? I'm doing pretty bad, not gonna lie. But that's okay. It's fine. I really don't like this weapon. There it is. What the fuck? Oh, nah, bro. But thank you for asking, Chapstick. Okay, I can maybe increase the sound of this game a little bit. To 20. Let's see how fat is. Ooh. It's kind of a bit loud.
Done playing games, monks.
But that's okay, that's
You're
okay.
ready for some divine judgment from me, Trant.
The fuck?
Maya wants to have all the fun fighting off Malawan, but screw that! That Tron guy is the worst, and I want to kick his dick off myself!
Oh. Okay then. Soleil? I love you. I love you too, Chapstick.
Ava, go protect the grain storerooms. Let the Vault Hunter take care of Malawan.
Ugh, got it, Maya. On my way.
There we go.
All I ever do is protect archives or storerooms or sacred whatever.
Yeah, that's an L for Ava.
Huh. Ava really took a shine to you. Might want to check your pockets. She was a stowaway on one of our seasonal merchant ships. We crossed paths. She tried to steal my book, and instead of throwing her off a cliff, I decided to train her as my apprentice. I've got my book
Okay,
and
then.
heading your way in a sec. I'm just finishing up some... Die, you corporate bastard!
Okay then. The fuck?
Ancient relaxation exercises. Much better.
I'm okay. Okay then. I'm gonna get a gambling addiction soon again. That'd be pretty nice. Damn, bro, nothing. Shit. Nothing, bro. Come on, brother. Come on, come on. Please, bro, please.
All right, Ava.
What the fuck?
Where is it?
There we go.
Not here or anywhere because died tickling the old ivories. You wouldn't think our clamps are
What?
suited to the piano, and they aren't. That guy's got a synthedope harmonizing module. Sounds like
I mean,
someone
spicy
had to
Nutella on
use their
toast.
kryptonite
Nice.
this
That was
time.
awesome. Slay, bestie. Oh, fuck!
Attention, rebel monks of
Did
Athena.
not mean to drop that.
This is Captain Tron again. I'm losing my freaking patience, so I'll say this as
How do I check that again? Social, I think. Mail, yeah. I mean,
politely as I can.
damn, this shit sucks. Damn, this all really sucks. Damn.
Please consider surrendering while we
I mean, free
trample
money,
your
though.
treasured heritage just 'cause,
I'm super
better
tired
than
now.
you.
Well, then, you should probably go to sleep soon, then, Chapstick. You should probably go to sleep soon. That would help a bit, I think, personally. Oh, fuck. Like, after you eat, just, like, take a nap or something. I don't know. Whatever you want to do. No? Oh, okay, my bad. Why don't you want to sleep? You tell me you don't want to sleep when you're super tired? What the hell? Okay, then. Okay, then. Shit.
I am through clan games. Unless that game is Kill the Monks. That'd be awesome.
Okay, then. I'm just joining random lobbies and shitting people. What game are you fucking playing, bro? I'm so confused. Bro, there we go. I want to talk to you. Oh, okay, thank you. That's so sweet. But I would rather you at least sleep. I mean, thank you. You know, I'm glad to hear that you want to talk to me. But like, sleep though. It's pretty nice. No, it's only a save point, or not? Yeah, whatever you want to call it. Womp womp. Okay. Don't care. Oh, my bad. There we go. I'm gonna be rich as fuck. There's really nothing over there, so like I'm fine. I can just continue on my way. I don't like how this looks personally. Yeah, probably a good reason. Oh yeah. Captain Trant. That's Trant. No, really? Oh, you fucking bitch. Is he also resistant to corrosive? No, he's not at least, so that's good. Zoomer, oh my god, that's awesome. That was so difficult. Oh my god.
Doggone dare, you wasted Trot? Good riddance.
Ah, he seemed all right. Apart from the old,
Oh, I wasn't
protection
pressing reload at all, that's why.
You got the iridium? Give it here.
Excuse me. Oh, nah, bitch. I can sell all of this fucking money. Because everything that I get fucking sucks. Fuck you.
I've never been able to use iridium the way Lilith does, but I Found a technique in this book that might change that. Okay, here goes.
Chapstick, I love you. Hope you know that.
It's working.
What the fuck? Okay then. That's awesome. I love you too.
Holy crap.
Oh,
I
they got
can
good.
phase lock a planet right now.
That's a bit much.
Teach
Then.
me that right now. I could get used to that
I mean,
kind
I
of
go to
power.
bed because I gotta get up early, but I ain't tired. Well, you don't gotta go to bed early, Monty. Think about it. You
It's
don't
making
gotta go to
sense to
bed
anyone
early.
else.
So, Ava, you survived the invasion. Guess all those hours staring at water taught you something after all.
I can handle myself. I learned to fight way before I met you.
Let's spar then, kid.
Oh, you know I would, but I've got a loot to sort through.
Nope. Go pack a bag. You get your wish. We're leaving with the Vault Hunter.
Boy, for real?
Woo!
I mean, yeah, cool, whatevs. Could be fun. I'll grab my stuff.
BRB, okay,
Vault Hunter.
bed.
Check this
Chapstick.
out. The Iridians left messages like these all over the galaxy. I always figured there was a connection between sirens and vaults. I can't read it, but it must mean something.
Okay then. Damn, this water looking really realistic.
There's no place in the galaxy with more science.
Wait, I wonder. Wait, no, wait.
Than Athena's. Must be something in the water.
Oh my god, this game looks. Oh,
But as long as Malawan knows it's here, Athena's
whoa, that's awesome. God, oh my god, put everything. Oh my god, no. Okay, good. Jesus.
He's safe. I should tell you this before I explain it to Lilith. The real reason I took Ava on as an apprentice,
Oh, okay.
she's going to be a siren someday. And I want to
What's
make sure
this?
she's ready when that happens. See you up in the stars, Vault Hunter.
Nothing. Really? Okay. Damn, bro. Inventory full. God damn. Okay. Okay, then. Okay, yeah, no matter what, it's fine, bro. It's fine. There we go. Got fast travel and shit, bro. Oh my god. My elbows do not like me at all. That's for sure.
Lilith tells me you have acquired a vault key fragment. Bring it to me.
Perhaps.
I shall keep it safe while you gallivant around in search of the other pieces.
Hello,
Chas.
adult human. I am.
Claptrap! Holy crap, I've heard so much about you!
Wait, what?
Yeah! When you took on the Bully Monks and Captain Flint!
Oh, that's awesome.
I make Maya tell me about it all the time.
That's awesome. I need to sell my shit, bro. I'm telling you. What is Claptrap on about, bro? He's on something. So the fuck, bro, fuck this. God damn.
You look tough.
There we go. Fuck, I just need to sell my shit. God damn. Oh my god. Okay, that favorited, thank god. Bruh. Okay, there we go. And then with all this money...
All I'm saying is, if you don't buy an SDU, you're probably going to die.
God. Wait, what? Oh, that's lost loot, damn.
Better buy up the rest, quick. This is very
Fuck, I'm
limited stock.
broke. God damn.
Carrying a load here.
Shit. Damn, bruh. Damn, for real. Here you go, I guess,
Vault key
Tannis.
fragment. Just holding this makes my skin tingle. That and
What?
I ate one of Marcus's discounted burritos. In case you were wondering, this isn't a complete vault key. Why the Iridians split the keys into fragments is anyone's guess, but the vault key on Pandora required 3 pieces. Still, it's a start. You should return to Lilith. I'm sure she and Maya have a lot of catching up to do, or whatever it is people with social lives do. No, thank you. Give me a sterile room full of surgical equipment any day.
Okay, then. Cool. What are you on? Okay, then. This is where I sleep. Motherfucker, I sleep nowhere, apparently. Let's go.
What do you mean, a siren apprentice? I can't explain it right now, Lilith, but she's going to be a siren someday. We'll talk about this later. What's up, killer? Maya says you kicked some major ass.
Ah, that was nice of her. I really put a lot of myself into it.
I believe it. Well, 1 fragment down, 2 more to go. So what is this all about, Lilith? Why is Malawan on a...
Damn. Okay.
Venus.
Oh, wait, shit.
Our key fragment has been a secret for generations. How did they find out about it now? I'm not sure.
I don't know how I feel about it, but that's okay. There we go. It's like this Monty Wall, bro. Oh my god.
Those seem to know more about the vaults than any of us, even Tannis. They knew about the vault map. Maybe they told Malawan to invade Athenas. They say they're after something called the Great Vault, and the vault on Promethea must be part of their plan. We have to get there first. We will, Firehawk. I'm not sure anyone calls me that anymore.
What do I want? Good question. What?
Things.
Wow, nice mustache.
Thanks. It's a Siege mustache.
Siege?
Cashed in on that Allies card.
Beatstar.
Got
I have
Atlas
never
have an
played Beatstar
asteroid-mounted
before.
Laser aimed at Atlas HQ, and he's threatening to slice me in half unless I surrender. I'm freaking out here. Freaking out.
Okay, 1 second.
And Zero reports the laser's being powered by a vault key fragment. So
My best friend
All I
DMing you?
need
Yes!
to hear.
Dude,
We're
you know
on
I'm antisocial.
now we're talking.
Download it.
Yay.
I am, bro! Give me a second! My Wi-Fi sucks. I have to use mobile data. It's taking forever. Because I'm in the fucking nowhere, bruh.
Go down there and help Reese with his laser issue, Vault Hunter.
I started playing like
I hope
yesterday,
Reese knows
lol.
what he's doing. Lilith says he's one of us, but can't trust a man with a mustache.
Can't connect it. Oh my fucking god, bro. I hate this shit. Dickhead breath. Wait, Beatstar. Touch your
So,
music.
The tattoos.
What?
You want to talk about it? Honestly, no. Not much to say.
Wait, what?
Gotcha. Well, I should probably get settled in. It's good to be back on Sanctuary. A Sanctuary.
Wait, what? Is the... It's a simple yes or no, bruh. Never mind. Just never mind. Okay. Okay then, my bad shit. Just I was like bruh, I am not gonna download nah. I'm not gonna download that shit, bruh. I'm good. I'm good. I fucking hate living in Seattle. Same here.
Hey, hi, how are you? You too, huh? Everybody wants a piece of old claptrap. And now I've got shade wherever I go.
Back. Hey, welcome back, Chapstick. Welcome back. Where do you want me to go? What the? What? Which the Meridian Complex? Which is where? Where is the Meridian Complex? Oh, it's in Promethea. In the Meridian outskirts. No. Fuck. I fucked up. What's going on in Arizona? Okay, hold up. Orbit View. What are you playing? I am playing Borderlands 3. Some pretty epic game. Need to go to... There you are. Boop. Oh, I remember this area, bro. You know what's a better game? Cataclysm 101 is a pretty good game.
It's Vault o'clock, baby. Meet me at, Launchpad 7. So Malawan has that laser on lockdown. There's no way your drop pod would get through security. But,
No? Yeah, it is, bro. You just mad, bro. You really just mad out here. No, wait, no.
I've got a state-of-the-art Atlas brand ship with cloaking. So, the plan is to fly up to the orbital platform and take out that laser before Katagawa knows what hit him.
I think I played Borderlands game a long time ago. Yeah, you probably did. It's a very good game and franchise. So yeah, it would make sense that you probably did at some point in time. Game goes hard. Oh God. Factual.
Hey, you got yourself a fragment! Making your own vault key? That's fun. You know what we
With my uncle. Hey, Pog.
An ever-hungry tide of ravenous followers sweeping over the galaxy committing super murder in our name. Just a thought.
I'm just queer, okay? I'm just slaying to the best of my ability. Stop hating, sister.
Polishing your gun.
That's called strategy, bitch.
Oh, look! Found some more
That's what
bandits
I'm
to
saying.
fight
Slay.
Good thing, too. I am starving.
Man, I want to just try that. Man, haters be really hating. That's just homophobic, in my opinion. Man, fuck that, bruh. Do I go all the way? Yeah, okay, I do. Yeah, no, I do not. Motherfucker, really out here. Yeah, okay. I learned my lesson. There you go. Hey, what up? Damn, bro, this gun goes hard, I'm telling you.
Still got it.
Meanwhile, in Idaho, this is Idaho. Yeah, makes sense.
You throwing traps at me now?
Boop. Oh fuck! You fucker! I'm sorry for my swearing. Oops. Man, that's a big ass fucking potato shit. I don't know, bro. Whoa, 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 whoa. Shit, bro. Oh my god. On God. On Jaw, my brother. On Jaw, I think, bro. Damn, bro. Can I even go that way? I don't think I can. Yeah, I can't. Shit. Okay then. Oh, my bad. I was about to pop a cap, bro. Shit, my bad.
Hey, you made it! My ship's right there. State-of-the-art Atlas cloaking, baby. This way. No, 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 no! Ah! Ah!
Damn, that's an unfortunate. Reese. Besieged and bestashed. The fuck?
Breeze, buddy. Giving that unconditional surrender any more thought? Or do you need another love slap from your old pal Laseroid to change your mind?
That's kind of fucked.
Screw you!
When you're ready, just
You
swing
would?
by with the paperwork. Can't wait to absorb Atlas into the Malawan family. Oh, and you can bring Zero. I'll bet he's
Yo,
interested.
the tangent line right here would be like
Before I hand over Atlas to that corporate asshat.
negative, yeah.
Plan?
And the tangent like right there
We steal
would be like
a Malawan
negative.
shuttle
Oh no, no,
with
it'd be
security
0.
protocols. Here, take this.
My bad. Hola, hola, hola.
So, the Viper drop is Atlas' state-of-the-art remote hack.
Now we'll use that baby to
Steal a Malawan shuttle. You in?
Already doing
I
it
gotta
in
go.
my
Bye. I
mind.
love you. Okay,
And a
okay.
moustache
See you,
spoil.
chapstick. Thank you for coming by. I love you too.
focus. Just find yourself.
I hope you go to sleep.
And pop in a Viper
Go to
drop.
bed soon. You
I
better.
do the rest.
Ooh, I'm shaking over here, bro. I'm just going like, whoa, going like, whoa. Pop, pop.
Okay, time to just gotta get in some
Or what? I don't know. I'll cry.
Viper Drive by Atlas. Yes, we're in. Reese comes through. High fives? Anybody? Okay. Hey, let me know when you're there.
Fucking flash troopers hate them, dude.
Did that one have a bounty? No. Not but a bustle of monkey gets.
What a fucking loser. Shut the fuck up. Oh, it's actually... Oh, okay. Okay, she's fine. She's fine. Skywell 27. Whoa. Whoa. Why is there... How the fuck did a piece of tape get in? The fuck? Man, I don't fucking know. Come on, like, just gotta maneuver it. Ah, shit. Look at me like I like their message. Bro!
Here, boyo. Nice view.
You know, man, I social.
I mean, of course that worked. and no death spheres in sight.
Death spheres, eh?
I'm on a different planet, bro. Wow, Newton's gravitational law would love this.
Head to the main gate. No death spheres.
Damn, bro. The mass of this planet must be very small compared to Earth's. Wow. Because of Newton's gravitational law and how it's inversely squared. Womp womp. sheesh. Bro, I be jumping and shit, like, I be going crazy. Womp womp. Damn.
Yes, the Sonora, Kanagawa's pleasure yacht. Rumor is he invited his siblings on board for a party, then murdered them.
Oh.
That's how he became head of mergers and acquisitions of Malawan. Oh, by the way, be careful with this low gravity. Might take some getting used to.
I thought he was gonna say, like, since it's a pleasure yacht that they did incest, so like, what the fuck? What's like murder? I'm like, oh, okay. That's better at least. I was about to say, the fuck is wrong with this guy, bro? Really fucking his siblings, bro. Oh, nah. But I was like, oh, okay, murder them. Okay, good. Whew, shit. I was very concerned for a second. I gotta go all the way back up now? Oh my god. Oh, nah. Oh, nah. Bro, can you climb on, Zane? Holy fuck, are you dyslexic to the hands? Do not ask questions at all. Fucking idiot. What are you, idiot or something? Oh shit, actually, okay, I do need to kill. There we go. Damn. Damn. What is blow? I do gotta get used to the new gravitational pull from this atmosphere. No wait, no, that's my bad. So like, wouldn't it have a different atmospheric pressure? Because of like the ozone layer and all that kind of stuff, and then the gravitational pull, and then we can figure it with Newton's gravitational law. Because it's mass of planet times the another mass of something. Damn, bro. Come on, bro. Come on. You bitch. Oh nah, bro. Oh nah. Womp womp.
I'm on fire!
If you...
literally.
Oh. My bad. Shit, homie. You read my mind. I was gonna say like, man, you want oh yeah, yeah. You ever said that, Monty? Right? I'll be a great mumble rapper. I swear. I promise. Bro, slow nigga like it's supposed to lie. Yeah. Give me all the shit that I need now. I need it. I need it. Damn, bro. Really give me nothing out here, bro. Oh my god. Give me some goddamn green beans. So funny.
That Dash and Fook over there with me.
Uh-oh. Looks like there's security up ahead. You take care
Just
of
doing that. There we
I
go.
will make sure they can't call for backup.
There we go. Powerhouse heavy, dude. Oh no. Why am I using corrosive? That's not good. Oh, that critical, that crit, bro. Oh. I mean, hard moaning and shit, bro. I'm telling you. It was hard. Fuck off. Man, I need ammo like all the goddamn time and shit, bro. Oh, get there's another like another thing and shit, bro. There we go. I'm gaming, bro. I'm just gaming. I'm just gay. I'm very gay. What up? God damn, bro. Fucking what? Oh no, that's not okay, dude. Fucking minimap, bro. Is playing Call of Duty out here for real. Bitch ass. Man, get fucked on, kid. Man, fuck you. For real, bro. Oh my god. Bro, leave me alone. Oh my fucking god! You fucking little nerd! Get fucked on, kid. Fucking nerd. That is so fucking cool. Oh, I fucked up! I fucked up!
I'll find you a way
Oh.
in. Pop a Viper drive into that console so I can
I'm
hack
good, I'm
security
good, I'm
and
good.
locate the fragment.
Yeah, I'm good, I'm good. Man, shut the fuck up.
Okay, fragment's not far. I'm gonna open that gate. There's reinforcements on the other side, so find some cover and ambush them.
That's a lot of work, though. I don't want to
Here
do that.
they come. Enter the base and pop a Viper drive into the security console. Then I will hack in.
Okay,
Locate
then.
the laser control room.
Help me end this war. Don't let the uniform fool you. I'm an undercover Atlas agent. My team was chasing some high-value
Okay,
intel, but
then.
the mission went sour. I managed to get out.
Like your love life?
But Atlas
That's so
soldiers
fucked me to
never
say.
die. Though I definitely will, very soon.
L?
After I complete my mission. You can call me Goner. Goner Malegis.
Oh,
Gallows
Connor.
humor. Now, look around for my agents. They couldn't have made it far. The intel we're chasing, it's a secret recording of Katagawa and the Calypsos. I hope it's worth it.
Okay, then. Folk really out here doing that kind of shit, bro. Oh, no. Oh, badass. Oh, I'm good, fam. I'm gonna get rid of the heavies first. Fucking hate the heavies. So they always be like my bitch and shit. Not like that. Hold up, hold up. Ah, shit.
Damn, you
There we
killed
go.
real good. Real good.
Yeah, I would hope so. Okay, then.
The main elevator leads right down to the laser. We'll be in and out so fast, Katagawa won't know what hit him.
What? Okay, then. Okay, then.
Now call the elevator. It'll take you right down to the laser.
Don't tell me what to do with my fucking life, kid. My God, I'm doing like shit, bro. Calm down. Just getting fucking nothing. Arrgh. Oh, there's so much shit to fucking take from. Telling you, shit's wacko. Wacko with a vacco. Okay, now I gotta take the elevator. Sadly. Damn. The fuck did I do?
Viper Drive. When you've got pink eye and can't open your front door with a retinal scan, we'll be there.
What?
Atlas. State of the art.
I'm in. Bypassing security protocols now. I said now. Now. Now, you stupid. Oh no. Reese, is that you? Welcome. So once we make your unconditional surrender nice and official, you and I are gonna partay on the Zanara. That's my pleasure yacht. Security, kill the Vault Hunter.
Oh my god, bro, just let me live already, please. Why it's so hard, bro, please. Fucking hate heavies, bro. There we go. I'm afraid that's my little fucking Jerome guy, bro. The fuck is you doing, bish? Give me that shit. Oh no!
Wait a sec. Reese, why are there Vault Hunters here? Tell me you weren't trying to take out my laser. It's my favorite laser, Reese. Oh, hey! Yeah, see the whole laser thing. Well, it's just making it hard for my employees to work down here. It's really starting
Bro,
to
fuck off, fuck off, fuck off, por
Who
favor.
cares about them? I'm doing this for us, the people who matter, the executives.
Okay, there we go.
But you're ruining it, Reese. You're ruining it by trying to defend yourself.
Damn, let's go.
Kill the freaking Vault Hunter!
Mobbing!
I can fix this.
No, you can't. The damage already done. Damn, bro. Fucking hate NOGs.
Damn it.
There we
Lock
go.
down the elevator. Well, let's see. Oh, hell yeah. Some spy stuff. Head through those ventilation ducts. They lead straight into the maintenance area.
Bro, really? Oh, nah. The fuck? Okay, then.
Crap. Search the body. We need that intel. Not there? Damn. Look around. That intel's gotta be close.
Damn. Bro, what the fuck are these people having, bro?
Let's have a listen.
Oh, I just...
Just a few more parts of the contract to go over. Clause 27. Malawan will receive exclusive rights to all Iridian technology found in the vault.
Fine with us.
Wonderful. Just wonderful. Moving on.
Interesting. I wonder if Katagawa has dirt on the Calypsos. We could release it and fracture their alliance with Malawan, maybe give Atlas a leg up. Which is one more leg than I have, I guess.
Money. What else?
All right, head through maintenance. I might have found a way into the laser control room. Oh, Reese. I know your
Okay, yeah, I
stupid
gotta through
vault
that way then.
hunters are skulking about. Better sign those surrender papers, buddy.
Jesus Christ.
Otherwise...
Target located. Laser fire in 3, 2, 1.
No, that was my favorite bagel place!
What?
Kagawa, you monster! Booyah! And that's only half power. If you don't surrender soon, Reese, I'm gonna slice you in half.
The fuck is...
Stupid Katagawa. I totally could have held him off. And then he allied with the
Sure.
stupid children of the vault.
Sure, buddy.
Those cultists have been working themselves to death. I can't compete with free labor.
The fuck? Can't I get up there? No, I ain't gonna try that. Fuck that, bro. That's gonna take too much work, personally. Whoa, please, please, please climb, bro. Please, I'm begging you. Please, climb, my brother. My brother in Christ, you gotta climb. Wah. Damn, it's locked. Damn. Damn. What? Okay, then. Oh, yeah, hold up. Shit. Yeah. God, how did I reset it? Wait, no, is that... There's like... Hold up. Hold up, hold up, hold up, hold up. I gotta check the fucking Discord. Yo! Har. Yo! Hello?
Yeah,
Oh, okay, bet. Okay. Well, then I'm gonna end the
you
stream.
turn the fan off. You need to turn the fan off.
Oh.